Hello, I'm MC Toon, and it's Tuesday night, and that means we've got a discussion, a debate, a conversation on the topic of the shape of the Earth. I have with me two people. I have Shane St. Pierre and Cracker, who I found through I don't know, a series of clicks somehow brought me to a video where Shane and Cracker was there too, were having a debate with somebody on flat Earth. I was the second view of that particular video, and I said, "Hey guys, would you like a little bigger audience?" And Shane said yes, and Cracker's coming too. So welcome, guys.
Thanks for having us, McToon. We appreciate it.
Hello.
If you want to introduce yourself a little bit so they know who you are.
Sure, we're just regular schmoes. I think we call us truthers. Did some digging about a year and a half ago when, let's see, call it January 2020. Looked into some stuff, found some stuff, flipped a lot of things that we thought were true. Let's see, researched a whole heck of a lot of rabbit holes into a field. And then we met each other, started posting, ran some truth channels. We have a Telegram group. We do YouTube, Odyssey, BitChute, Rumble, RoxyTube, Brighteon, Minds, all the good stuff. Everything but Facebook, Instagram, and YouTube, essentially. And I found Cracker on Odyssey via comments when we were talking back and forth about one of the flat Earth topics. And we first yelled at each other, tested each other, and then became, I think, fast friends. And we've been kind of working together ever since.
Yeah, as far as me, I don't think it's really important who I am.
The Invisible Man, that's his moniker.
I think that it's more important to display the flaws and the reality that we've had built around us. It's sort of like Pavlovian training, and we've fallen into it. And, I first started thinking about it even when I was younger. I didn't understand how some of these things were actually a reversal of natural law. And then it just kind of went along with it. And then it hit me again when everybody started to kind of wake up to all the bullshit with the government and everything. And you investigate everything. You question everything. You cannot set anything aside in this current situation that we're in right now, because we've been literally lied to about almost everything, with little bits of truth.
That is the truth.
So that's what we're here for, is to find the truth, not to just believe things.
Belief is the enemy of knowing, for sure.
Well, good. So you have some non-beliefs about the shape of the Earth.
I do. There's a lot we don't know. There's a lot that we dismiss from the given taught heliocentric model, and there's a lot that we suppose or guess at that we don't really know for sure.
And there's a lot of straw man models that are built around flat Earth that we do not accept.
Yes, sir.
That people assume on the flat or the globe Earth side that we do accept, or there is no necessity for a model. The only thing we have to prove is that it's planar in nature, or it has a foundation and that was built upon, but the foundation is indeed flat.
100%.
And that's the only evidence that we need.
Show us how we're wrong, McToon.
I'd love to see the non-belief based evidence of that. So you said that you wanted to be able to share your screen.
Sure.
And let me hold on a second. I think I need to adjust the settings in Zoom. It defaults to more secure, which means you cannot by default share screen. All right, there you go.
Would you like me to share and get going, or you want to take us off on a topic?
Yeah, at your discretion, go ahead with your stuff here.
Oh, you good to go? Everyone see what I'm looking at?
Yep.
Whoops. There we go. So let's see. Start with the reference. Prove all things. Hold fast to that which is good. Theologians 5:21. I love that one. I was 18 years of Catholic school before I thought myself out of religion, right? I was atheist after 18 years of ritual and CCD and ecclesia and all the study of the church. And then I discovered flat Earth, brought me right back to God. I think you'll find the same story with a lot of us. So let's see some starting points. Mr. Isaac Newton was quoted, right? Sometimes we speak of gravity as essential and inherent to matter. pray do not ascribe that notion to me, for the cause of gravity is what I do not pretend to know, and therefore would take more time to consider of it. Love that one. It's also a little poignant when he's the foundation of the gravity field science examples and, I guess, thesis that runs the heliocentric model. This is sort of a starter. Everyone who's a flat earther was taught everything you're taught. We all took 4 years of astronomy, high level science, all that stuff. And then we looked into it to prove it. And then that's why we discovered that all that's wrong. This right here is us to be provable. We can prove this, measure it, sense it, observe it. Everything about the heliocentric model is relying on experts or the Hubble telescope or stuff that we don't have, technology we can't prove, or hearsay from supposed experts, right? But everything you see, hear, see, and sense is flat. Let's see. Let's keep that. So a lot of the flat earthers know a lot about the globe model. I mean, I was watching one of your interviews earlier today, and that guy didn't know anything about it. But he doesn't represent us. Most of us know all the details of the heliocentric model, how fast it's spinning, how far away is the sun, radius of the earth, tilt, the 23 wobble, the seasons, all that. So when we found the flat earth counterexample of how it would work, it was simpler, more elegant, didn't require all sorts of complex notions, and everything was justified and explained perfectly, at least to most of us. That's the quote I started off with. Belief without reason cannot be convinced by reason. I love that one. Works for a lot of things. Hey, here's the 10 top things why the Earth is round. Have you guys seen this? let's see if you agree. It's 2 minutes.
Number 10. All the other planets and stars we've ever seen are round, and there's no reason to indicate that the Earth should be any different.
I like
Number
that
9.
one.
Time zones. Day and night happen at different times at different places on Earth. In fact, it's always day somewhere and night somewhere else. Number 8. The Coriolis effect means freely moving things like cannonballs or hurricane winds are deflected to the right, but only if you're north of the equator. If you're south of the equator, they're deflected left. Number 7, triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again, and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles. As any geometry student can tell you, this is impossible on a flat surface. Number 6. The sun, in general, gets lower and lower in the sky as you travel away from the equator, and you can use this to directly measure the Earth's curvature. Pick 2 places a few hundred miles directly north and south of each other, and at noon measure the shadows cast by a vertical meter stick at each location. You can use the shadow lengths to figure out the angle between the sticks, and once you add in how far apart they are, you can calculate the Earth's curvature. Number 5. The stars at night change as you go north or south. For example, Orion is upside down if you're in Australia. Number 4. Ferdinand Magellan, and many people afterwards, circumnavigated the Earth. That means he left headed west, continued going west, and came back to where he started, still going west. Actually, Magellan was dead, but one of his ships, led by Juan Sebastian Elcano, finished the journey. If you head west and circumnavigate the Earth yourself, you'll be able to tell because you'll observe one fewer sunrise than everyone who stays at home. Number 3. The horizon. Ships on the ocean or tall Chicago buildings viewed over Lake Michigan disappear bottom first. And you can see the sunset twice if you watch it lying down and then quickly stand up. The simple fact is, if the Earth were flat, there wouldn't be a horizon beyond which things could disappear, so from across Lake Michigan you'd be able to see all of Chicago, as well as the Rocky Mountains. Number 2. During a lunar eclipse, the shadow of the Earth on the moon is curved. And number 1. We know the Earth is round because we have photographic evidence.
Do you agree with those examples? Do you have better examples, or are those not working for you, or are they all good?
Those are all pretty good, yeah. I think probably like 9 and 10, I think I might not reference, but the others
a little weaker for sure. You think
pretty
those
good,
are all
yeah.
valid though? All right. I think we can, destroy each one of those tenets if we want to go into it. But why don't we ask you
the task was for you to show the evidence for flat Earth, right?
No,
Because you said it was explained perfectly. Flat Earth was always explained
Right.
perfectly.
it's testable and repeatable and measurable by our standards and metrics is a better way to phrase that, right? Everything about the heliocentric model comes from textbooks and, astronomy and equipment that we can't access and equations that we don't understand. Would you agree with that?
I agree that you don't understand it.
Fair enough. So, I mean, the sun rays is what did it for me personally. The local sun, it's a local object, right? It's about, say 32 miles across-ish. We don't know how far up, but above the clouds within the Earth system, local monitoring light source, right? So let's see. We don't need sound for this. There we go. So this is the heliocentric model of how the sun rays hits us, right? 93 million miles away, and they don't come in parallel, but only because parallax. It's so far away that we see them, and I think you would say the corpuscular rays that we see is some sort of refraction.
So
we
well,
think that's nonsense.
A couple things. First, parallax is not. This is not parallax.
The sun's rays from 93. Sorry, you're right. My bad. The parallel rays, right? 93 million miles away, the sun's rays come in parallel, but we don't see them parallel.
Very, very nearly parallel. Yes.
Yeah, we disagree with that entirely. But let's see here. So, my two examples that really brought me over was the sun in front of the clouds with filters in front of and behind clouds, and how all the stars circulate in perfect time and perfect synchronicity year over year around Polaris. If we're spinning around, let's see, how fast are we going around the sun? I think it's a million miles, 666,000 miles around the sun, 300 and something thousand miles around Milky Way galaxy, and we're spinning, rotating, but every star stays the same in a perfectly circular pattern above our head since the beginning of recorded time. Odd.
But they're not. They're not exactly the same.
What do you mean?
They move. They're in a different place all the time.
Well, if you look at where they are, if you look where they are right now today, and then you look at 1 year from now, it'll be in exactly the same spot.
No, they're not. In fact, they all move.
So how do they do the annual calendar and prediction of the eclipses and all that stuff if the calendar is not to be relied upon?
Well, the calendar and the eclipses don't have anything to do with the precise positioning of the stars. So
the calendar is exactly the position of the stars, isn't it?
No, it's not. You claimed that the stars don't move, and I can simply show you documentation of the stars moving over time.
They go circular in a circular pattern in a perfect circle around us, right? Like this.
So you didn't go into this particular rabbit hole. I mean, you're sharing now, but so I can't. But Polaris, for example, is the North Star, and I have 150 years of documentation of Polaris. So in 1850, it was 88 degrees 30 arc minutes in position, which is about a 1.5 degrees from the center of rotation. In 1900, which is 50 years later, it was 88 degrees 46 arc minutes, so about a quarter of a degree closer to the center of rotation. In 2017, it was at 89 degrees 20.3 arc minutes, which is less than a degree. It's about 2/3 of a degree from the center of rotation. So the documentation of the movement of the stars is not difficult to find. It's in the nautical almanacs because their positions are quite important.
What was your earliest date there that you tracked the position of Polaris?
1850 for this particular documentation that I have. It's at mctoon.net/Polaris.
Have you heard of the Georgia Guidestones?
Georgia Guidestones are about 3 or 4 degrees wide, and they've only been there for 30, 40, 50 years, something like that.
Since the 80s, I think.
Yeah, right? So the margin of error of the Georgia Guidestones are somewhere in the range of 4 degrees. The measurements that I gave you are better than 1 arc second of margin of error. An arc second is 1/3600.
It seems that all of this would be irrelevant because you have to prove Coriolis effect.
That has nothing to do with this topic. So let's
absolutely it does. You have to prove axial rotation in order to assume that the stars are in place all the time.
It's a totally different topic.
But there's a hole in the Georgia Guidestone, a little hole right in the middle.
Yeah, like I said, it's like
that sees Polaris
4 degrees wide.
And we think that, so you're of the belief that our North Star changes over the thousands of years?
It's not a belief, it's documented.
It's written in a textbook for sure.
It is factually measured, yes.
How would you prove that yourself outside of a textbook? Just curious.
I mean, you could go if you disagree with it.
Did you get in a time machine and go back to 1850 and measure it yourself?
He had asked me a question. I'll answer it, then you can come back up with that, Crackers.
Yes, sir.
So if you disagreed with it, this is a basic tenet of science. If you disagree with it, then the door is open for you to show that something is wrong. So if you think it's wrong, then definitely show that it's wrong. So you would then maybe want to go get a angle measuring device, maybe a nice telescope, that can measure to 1 arc second and see where it is in from year to year. So,
But how would
Polaris-
you verify that it was 2,000 years ago different than it is now? How would that ever be verified by one of our generation besides looking in the same
Well,
textbook?
of course, you couldn't personally do it, and science doesn't expect that you can personally do everything. You look at the documentation, you evaluate the evidence, you look to see that many different sources over time have confirmed the same information.
I mean, to us, if we can't prove it ourselves, we kind of put it in the maybe category. And if they tell us that 2,000 years ago Polaris wasn't where it is now, cool story,
I don't know
bro.
why I keep bringing up 2,000 years ago. I only cited 150 years ago.
I'm just because I know that the story of Polaris is that it shifts over a great period of time, but our human existence is short, not too short to notice it, essentially, right? So the change we wouldn't notice in our lifetime.
Definitely not too short to notice. You could definitely get a measuring device that's accurate to 1 arc second. We call them theodolites, and then you could measure the position of Polaris yourself. You could do it yourself. If you thought it was wrong, then
I'm not
then
saying it's wrong. It's never
absolutely-
changed.
Absolutely, you go crazy and show that all of these people whose careers sit on the positioning of the stars being accurate, and they know it.
Oh,
they
maybe that's
deal with
part
it.
of the
They
problem.
work with it. That is their field of study,
Mhm.
and they sit on and. But absolutely, it would be fantastic if you thought it was wrong to show that it's wrong. But just saying "nuh-uh"
Right.
isn't
I'm not saying
actually
it's
valid.
wrong. I'm saying where it is now is where it's always been, and no one can prove otherwise. That's what I'm saying. You can't measure it in your lifetime an arc second. It doesn't vary. It's been there.
Yes,
it will
you
never
can.
move.
All you're just saying "nuh-uh." That's all you have is "nuh-uh."
No, I'm saying it's not measurably variable from anyone that we've ever.
That's it's just your claim, but people do
Fair
it.
enough.
You
Who?
don't. You've never done it, so you're speaking from a position of ignorance. You've never done it, and your only offer is "nuh-uh." That's all you have.
We're speaking from our own perspective, which is all we can ever do.
Yeah,
and
but
if someone else claims,
you didn't measure it, so you cannot speak from a position of knowing it. You can only make a blind faith-based claim that Polaris has never moved.
I can say
you
it's
don't
in the
have
same spot.
No. You'd only have a belief that Polaris has never moved. You don't have evidence that Polaris has never moved. You've not measured it yourself. So by your own standard that you started with, you cannot say that Polaris hasn't moved. It's only a faith claim that you're making.
I've measured it, 10
You
years
don't have
ago
evidence
today,
of
and it hasn't changed at
Coriolis
all.
effect?
Where
If I measured
you
it-
measured it to better than in 1 arc second.
It never fluctuates.
These
man.
are
I've measured it
irrelevant.
and measured it and remeasured it, and
This
it's
is
never moved.
irrelevant.
Cracker,
Because-
it's his
but-
topic. It's his topic. I did not bring up this topic. Shane brought up this topic.
I've never heard anyone say that it's moved. That's why I was like,
The blind faith claim that Polaris never moves, in contradiction to the actual centuries of measurements of the position of Polaris. So
Fair enough.
the burden of evidence is on you to show that these are wrong. And if you measured it 10 years ago, I'd love to see the measurements that you made better than 1 arc second accuracy. I'd love to see that.
is there any
that.
deviation for 1 arc second from one measurement to another?
How
you
does
use it?
this prove that the Earth is a globe?
It doesn't. We're on a different topic,
It's-
I think.
yeah.
I've never heard anyone say that Polaris has moved. Have you, man?
No,
I've never
I've
heard
never
that
heard
before.
that.
You've
So
been
we'll
in an
move on
echo
from that
chamber
one.
for too long. Maybe venture outside the echo chamber a little bit.
All right.
Listen,
Well,
we learned the same thing that you did in school.
I don't.
We
think
grew
so.
up believing it.
I strongly disagree.
And you know what?
That's
okay,
fine.
I want you to give me an example of any flat earther that's ever came back to the globe.
no one has, but he wouldn't know
Ranty,
that, man.
speak
Who?
truth, speak truth.
Oh, Ranty.
Jose
who got
JG
paid to come back.
Gonzalez.
Yeah.
Wait. You
Oh, you
claimed
can
that.
name
Hold on.
two.
Wait, Cracker.
Who
Hold
are
on.
these
Hold on.
people?
You do not. You must not, because your own. Well, maybe you disagree with Shane, but I was figuring that you do.
Are you
Shane
whining
said.
because you're losing people?
Shane said that you don't make faith-based or belief-based positions. So if Ranty
that's not
was
what I said.
paid,
Like
then
those things
please
that don't have
provide the
experimental evidence like
please
gravity?
provide the evidence
Like
for
Coriolis effect?
Hold on. We stick to the same topic unless you're scared of it. I could understand, but you claimed very
Oh,
specifically
shit.
that
Come on, stop with
Ranty
that ad
was
hoc.
paid.
Calm down, man.
Stick
So
to the
you said
topic.
that Ranty was paid. So now that is a faith claim at this point. Do you have the evidence that Ranty was paid?
other people are
That
relevant, right?
is
We're good.
irrelevant to whether you're
You
trying to prove
made
whether we
the
live on a
claim.
spinning ball in a space
You may,
vacuum.
I get that
These
you
are
want to
your
deflect off of
claims.
this topic because you know
Okay,
you don't
no,
have any evidence
stop.
supporting that
Mr.
claim.
McToon is right on this
You-
one, man. We did say that, and he's right. We didn't know those people. They made a comeback. We don't know that. Fine.
Cracker, if you don't have evidence for something, I mean, unless you disagree with Shane, please be
have
aware
you
that
lost
I'm going to
more
hold
people
you to
flat
that.
Earth, or has flat Earth
Cracker,
lost more
Cracker,
people?
I'm going to hold
globe?
you to that standard of evidence. If you make a faith claim,
This
I'm going
is
to call you out
irrelevant
on
to
it.
whether the world is a globe or not.
You
This is
made the claim.
completely
I was at. Let's
I
back
don't
up.
give a shit
Let's back
about
up.
the claim.
I was
Calm
asked
down, man.
Pointless.
Hey, I was asked
Whether
who
Randy was paid or not does not prove whether we live on a globe.
But why was I
Moving
asked?
on.
Why was no?
Moving on.
Why was
Moving
I
on.
asked if there were any flat earthers that ever left flat Earth?
How
Why
about
was that
doing
asked to
something
me?
productive?
That
like
was
prove gravity
asked
and
to
show me
me.
experimental
We
evidence.
claim that. You are right, sir.
All right.
Thank you. All right, Cracker, you need to kind of think about what you're doing here. Shane is on point here.
I mean,
Okay.
we're not
But
confrontational here. Let's take the
This
emotion
is
out of it, bud.
irrelevant.
True. Fine. Let's,
Okay, drop it. Okay, I'm sorry.
well, no. There we
I
go. That's
might
cool.
be wrong.
Cracker, I love you,
Okay,
man.
do you like to hear that?
Thank you.
I've never heard
I
that
appreciate
before.
that.
Okay,
so-
this doesn't prove that the Earth is a globe or flat.
I was
Moving
just
on. This
observing
is
that
the point.
for me, the stars seeing
Good
and
Lord.
appearing to me in a circular pattern, and the sun appearing to be above and behind and in front of clouds. That's personally what raised my alarm. That was my observation and jumping off point, I think. Right?
Okay.
Fair enough. Have you refuted the sun being in front of and behind clouds at the same time, or is that something that we made
I've
up?
never
or-
seen it with a solar filter on.
Okay. How about, let's see, where is it? This is a solar filter, is it not?
That's not a solar filter. That's a digital filter.
What is the sun?
That's a negative filter.
That's
However.
that's not a solar filter. A solar filter is
Correct.
a piece of plastic that goes in front of the lens. So that's a
To be
digital
able to look
filter
at the sun.
done in Photoshop or a video editing software.
So that would mean, let's see, where's that one? I want to see I've never seen a solar filter, right? So this is like when you look at the sun directly like this, you wouldn't be able to do this
that's
without
not
a solar filter.
Yeah,
or
you're
no?
just seeing glare.
Yeah, all right. Fair. Anyway, for this one, do you think
That's
that
not a
this
solar
is?
filter.
I don't know. It's
Just
not.
because it
It's
says
just
solar filter on screen, you can tell
It
that it's not
doesn't.
a
It
solar
doesn't say
filter.
that. I made that up because I didn't know what a solar filter was, so that's my bad.
Okay. You can make your own solar filter with welding
Bella.
glass, for example.
What's it made out of?
Hello.
Welding glass is glass.
I mean, the opacity to see what the. Never mind. Moving. Hey, Bella, I didn't know you were coming. That's Bella. Sorry about
We've
that.
got Bella.
Hi. How are you?
One of our groups. So
Put
this,
the link in chat, so I was like, might as well.
yeah, forgot.
They
I
put the
it-
Zoom link in chat.
There's only 8 of us, man, and I didn't know
Okay.
you were on, Bella. I was just like, Cracker, we're at a meeting, and here we go. So this footage of the sun with local clouds is the other one that got me, right? So let's see. So we got the bottom right, the real filter, the regular camera, and then the top, of course, the negative filter. And as it approaches,
Okay, I know you've been waiting.
we don't need him
Check this
No
out.
kidding.
right there.
Now, if you was on the other side
Hey,
of the sun,
but that's not a solar filter.
all these
Show it with the
clouds-
solar filter.
But the clouds are clearly in front of and behind. Do we need a solar filter to see clouds?
well, they would
Yeah,
look
you
perfect to if you
definitely
was
need
on the
a
side
solar
of the sun,
filter.
like these
So
clouds right
if you
here.
don't
So
have a
this
solar filter,
refraction?
that's fine. That's not refraction. That's glare.
Now,
I was joking. I'm sorry, man.
that's on the other side, though.
The one interview I watched, you guys talked about refraction for like 30 minutes, so it's in my head.
Yeah.
So is this what fakery, not misdirected
You're
videography?
You're seeing that the sun, which is very bright, is shining brighter, bright enough that the thin clouds don't obstruct it. But with the solar
But-
filter, you would see them.
It's light in the front of the clouds and dim on the clouds behind it.
But now
clearly.
if the sun is inside the clouds, as this must demand, then you would definitely have it somewhere around a couple miles high, and the sun moving through the air at that speed would cause a large number of you'd hear sonic booms all the time, and This video,
Why
it
would you
wouldn't
assume
be,
that?
it would not be moving that slowly. It'd be moving 1,000 miles an hour or something like that.
But the sun moves about, it's the perfect clock, right? It rotates just above our Earth, and it
If
rotates
it
in
does
time about
rotate
twice
just
a day.
above the Earth, it must move at thousands of miles an hour.
No,
No.
Okay,
not
well
if
then,
it's
then what's the circumference of the trail of the sun? And
nobody knows.
We don't know.
yeah,
We know it's
but we
about
do.
74 miles up.
It's actually
we
not
don't.
that difficult because there is a subsolar point. People know where the sun is directly
How do
above
you-
them.
You say the
Every
sun's
day.
93 million miles away. How do you prove
It's
that?
90 million miles
Calm
Okay,
down,
away.
everyone.
different
Calm
topic.
down. Calm down.
Different topic.
No,
And I'd
I'm
be
just,
glad to show that. But once you establish how the sun is moving that quickly through the clouds.
Well, if you think that everyone sees the sun as a point above their head, well, how would the solid object appear to be in the same spot from everyone's perspective? Wouldn't that be more akin to a light on a mirror if everyone is seeing a reflection of the same object? That's the only way we can
would
see
be
it from the
on
same
you to
spot.
provide the supporting evidence for that. So, go
Oh, I'm
ahead.
just talking.
I agree.
All you,
agree.
But,
it's a hypothesis so far. You need to test and confirm it.
How about
Not
the
a
sun in
How
the
do you
Ant-
confirm that the sun is 93 million miles away?
Yeah. When you're ready
Do
to
you
go to
have
that
any
topic,
do you have
Absolutely.
any confirmation of that?
certainly. When you're ready
Well-
for that topic, I'll be glad to go.
When
over
I'm
it.
ready, I'm ready now.
No, you're all right, man. You
Shane's
take it
fine.
away.
Can
Here
we
you go.
hear,
I'll show you.
can we hear
Here.
some evidence?
Go ahead, man. Do you have a? Well, I
Yeah.
just want to show the Antarctic sun. Have you seen this? Anyone? The triple sun, the appearance, the refraction, or
Yeah,
the doppelganger.
they're called ice dogs.
What about the
Or
video
sundogs,
where they're
sundogs.
standing there watching the sun literally just go in circles around them?
In
this one?
Antarctica?
No, the Arctic.
The one in Antarctica is
I don't know. Hold on.
This
It's
one.
on film.
So that's, I mean, this is the
Yeah, those
the
are
triple
sun
sun.
dogs.
But how come it only appears in the Antarctic?
It doesn't only appear in Antarctic. I live in Minnesota and I see it, but only on very cold days when there's ice particles in the air.
Have you put that on your website as a picture?
I posted it on Facebook. I haven't put it on my website. I don't think.
Personally, I'd love to see that. I've never seen it anywhere else. I'm not saying that you're lying, but I'd be curious to see that for sure.
It was about 20 degrees below zero freedom units.
Let's do. Does anyone know why the sun sets? The limits of ocular perspective.
I'd love to see the plausible explanation for that.
Well, we can mimic it. An example that we can repeat in our house with a light and a string, right? So if we do this little setup, we got some obstacle courses and we have a light on a string.
Yeah,
Right? So
hold
this
on a
is to
second.
mimic the. Yep.
Let me ask a question. What can you close that little thing there? That more videos deal.
Sorry.
There you go. Okay, so those bottles with that piece of cardboard. What is that there for?
That's just to represent mountains or obstructions of any sort.
Okay, but so not water. So this isn't representing over water.
It's not.
Okay.
So we just have a circular object moving in a straight line across our perspective, right? To us, and then he brings it all the way back.
Yeah.
Let's see. Let's do it from this side. So then from this side, when we look at it from the same perspective, as it goes on the same straight traversable line path, it appears to be setting. It appears to recede because of the limits of our ocular perspective. The angular perspective that we can see judges it from our perspective as it going down, but really it's just going away.
Let's see it.
And it's moving about the same speed as the real sun.
It's getting smaller in angular size.
It is, as the sun in the sky does, right? So it appears to be setting, no? And then it sets behind these obstacles as it would a
Yeah,
mountain
well,
or a building.
it's getting obstructed bottom up by an obstacle.
Our sun does, exactly.
That's what an obstacle, like the curve of the horizon, like you see over water. But there's no
Sure.
mountains. There's no mountains in the water. So
But there are mountains that the sun sets behind.
So
no?
the horizon
Certainly,
is a
but-
physical curve.
But why did this doesn't show the sun setting on a flat surface? as
So
you claim.
the
This is an
horizon
example of an
curve that
object moving in a
makes
linear way that appears to
Yeah,
be setting.
and getting
That's what I'm trying to
obstructed
go
by
with.
an actual physical thing. So
Mhm.
you didn't support flat Earth here.
I'm just showing that an object moving in a straight line can appear to be setting from our perspective. You're not going to give me that, McToon?
And because I can do a little bit of math, I can actually calculate how high the sun should appear for flat Earth.
Are you assuming that we can't do math?
No.
I've never seen a flat earther solve a triangle on their own.
Oh, really?
Solve a what?
That's interesting.
Like Pythagorean theorem? What do you mean solve a triangle?
You mean those curved triangles that you try to use to justify your calculations for a sextant?
Is that a test you throw at flat earthers?
I don't generally, but
I didn't know that
but
triangles had curved sides. That's
Cracker.
interesting.
Cracker, if a triangle has sides 1, 1, and 1, what are the internal angles?
30, 30, and 30?
Well, I would go back and ask you, what's the definition of a triangle?
Well, this would be a planar triangle.
Triangles made, yeah, you mean one made with straight edges, right?
Yeah, I said a planar triangle.
So
So,
how
that gives you everything.
That means straight edges, right?
It's a
It takes
planar
us
triangle.
It's the one
two
example I put in the
lines
beginning
making
where they
an
said it can
angle.
only be on the
Definition of
globe,
an
right?
angle is two lines that convert to make an angle, right? They're not curved, they are straight.
On
30,
a
60, 90?
planar triangle. Yeah, you're correct for a planar triangle.
I'm asking you, are you saying that your planar triangle has curved lines?
No,
Now I see
planar
why it
triangles
was a
have
test.
straight lines.
Okay.
So how
What's
many?
the answer?
Yeah,
30, sorry.
Cracker. What's the internal angles? This triangle sides 1, 1, and 1.
Oh, we don't know.
Oh, gee. Ugh.
But I've never seen a planar triangle either. Not that that counts, but
You've never seen a planar triangle.
I mean, I've never had the types of triangles. I don't remember my basic geometry. So there's a regular triangle, the right triangle, those are the ones I remember.
A planar triangle would be a triangle on a plane. And when
Like
I
the-
said that it has sides 1, 1, and 1, it
Yeah,
tells you
60 degrees, 60
45.
degrees, 60
There
degrees
you
if you're
go.
using the correct
45,
math.
45,
Yeah.
45. Got
All
it.
right, that's good.
So
And
I have one right here. There you go.
is that one that you stump flat earthers with?
Well, I gotta say, a lot of flat earthers don't.
oh, gee,
Don't
that
quite
proves
get it.
Hey,
us
we
wrong.
didn't. I didn't know what that was, man.
Triangle.
Now,
Anyone else want to take over? Go ahead.
yeah, just a
I'll be
second.
right back and
I
you get
got
something to
something
drink.
to show you.
Yes, sir.
All right.
Let's see.
Well, gotta change the scene here just a second, since you're not sharing.
There we go. Oh, I did stop. Okay.
There we go.
Well, since Cracker is not on screen, I'll just do this. All right, so
Yeah, I don't need pictures.
here is
I don't
here
need
is,
cartoons. I mean,
here is an actual sphere. You see this? It's an exercise ball. So on a sphere, you can do
There
a
we go.
triangle, and these lines are pulled. I got them straight here. They're a little lax because it's colder
There we
in
go.
here than when it was. But you can see these are what are called straight lines on a sphere, are called great circles. So when you put a triangle,
well, I
on
was
this-
under the impression
I
that
wasn't.
Let
I
him-
wasn't.
were
Let him finish,
straight.
man.
All right. When you draw a triangle on the surface of a sphere, and then you sum up. Oh, this one's loose. When you sum up the angles, right? You can add these angles up. They add up to more than 180 degrees.
Gee, you don't say.
Third dimensional, right?
So that is called a spherical triangle. It is a real part of geometry to do.
Do you have any citation for that?
Yes.
No, I remember learning
Yeah,
that, and then I just
Spherical.
Spherical. Yes.
I've never heard lines being used to make a triangle that
It's
were
a weird
curved.
one, but I put it out in the first thing I shared. It was in there, wasn't it? The very first. Did you see that? It showed the triangle. It was one of the globe proofs. It said this only is possible out of globe, and we that's what you're referring to, right?
Yeah.
Yeah. I mean, that doesn't
is-
have any real life practicality to us, but it is true and it is valid and it does work
All
out.
I will.
Hang,
show.
But that's
for-
not the geometric definition of a triangle.
Why?
Triangles are
specific
Hold on a
one.
second.
three angles,
Just a
and
second.
angles are made with
Let-
straight lines.
let me share to you, so you know that I'm not making this up. This is long-standing.
You do this for a living. We trust you on this, man.
This is long-standing geometry. In fact, it's referenced in by Euclid in his Phenomena
Way back when.
2,000 years ago.
Oops.
It's really funny that it's Wolfram.
Who?
Y'all know about Wolfram?
So this
Y'all
is
know the
like this
symbology
is
behind
supposed
Wolfram.
I don't know who that
it's supposed to be a projection then.
is. Mhm.
What's it?
A projection, not an actual triangle that's
No, it's an
defined
actual.
as a
I mean,
triangle.
I put an actual triangle on this sphere. A real triangle is on this sphere.
Correct.
So if you disagree with putting a triangle on a
Come on.
sphere, I mean, I have it right here. It's going to be kind of difficult for you because I have a
nailed
physical
it.
example of
You
it.
nailed it, sir.
Okay,
You are right.
And if you sum those angles, they will be more than 180. And on screen is from Wolfram. And I don't
Right.
care about symbology. If it's wrong, it's wrong. If it's right, it's right. So if you think it's
No,
wrong,
you need to care
then
about
show where it's
symbology.
wrong.
You really need to care about symbology.
So
You
Well,
no,
no.
I
Not
don't
here,
care at
Bella.
all. I literally
Yeah,
care
and
zero
that's going to
for
be your
symbology.
problem. That's going to be your problem.
Calm down,
moving
Bella.
forward.
Chill
You'll
out.
stay asleep until you
if-
actually fucking learn something.
If symbology is important, then you would have some
It
evidence
is
to support it.
important.
So here is from Wolfram Alpha, and I do this because they have a nice website and a nice drawing, but you can go back thousands of years. Spherical triangle, spherical trigonometry has its own
Sure.
axioms.
I agree. I remember
There's
learning it.
nothing about it.
It's
that
just not
is-
the place we live on. But
But when you measure triangles on the surface of the Earth, you get more
Of a
than
sphere.
180 degrees,
I have a little
telling
simple
us-
question.
telling us that
Um,
they cannot be planar triangles.
I do have a question for you.
Okay?
What shape do you actually think the Earth is?
The Earth is a sphere.
It's not a
not an oblate
Okay,
spheroid.
not an oblate spheroid or a pear or
It's an imperfect sphere. The best word is geoid.
okay.
Do you think it bulges at the
could you
equator?
God never
possi-
said sphere. God said round. Round doesn't mean sphere.
It's okay, Bill. We're not using the Bible
well,
here.
Hey, I'm just saying.
She just did, yeah. She's just saying.
I know the Bible never convinced me of anything because I was already a Catholic who already disregarded all of it, right? So I don't tend to use those
so
as
it's
Hey,
an
I came in
imperfect
late, so I
sphere.
didn't know if there was a stipulation on me using the Bible or not.
Hmm.
And I'm not
If-
one who actually follows the
New one
Bible.
for me.
So, boom.
So let's see here. What were we doing? Do you think the Earth is a oblate spheroid and it bulges at the equator because of the centrifugal spin of the Earth? Is that correct?
That's right.
Yeah, the centrifugal spin that spits the equator out but sucks everything else in.
No,
No, I mean-
centrifugal force does not suck everything in.
So
Centrifugal
does that mean
force
there'd be
is an
a
outward
mile high,
force.
bulge of water in the Pacific when they're doing a transatlantic flight when they go from the north to south? Would they have to go up over the giant?
No, because what happens is sea level is what bulges, and so there's about a 24-kilometer difference.
I've never
between-
seen the sea bulge.
I'm sorry,
No,
I
no.
wasn't done talking. From the equator to the poles, so that bulge is
Have you
distributed-
measured that yourself?
I'm sorry, I
Let them
wasn't done
talk,
talking.
fella.
That bulge is distributed over 24,000.
He has
So
to
it's
say
12,000
imperceptible
miles.
then. Imperceptible
It's
to
not
us.
enough
Okay.
to see. Yeah.
Gotcha.
I'm
All right.
asking him, has he gone and measured the bulge himself?
No,
I
I've
don't.
not. I've not measured that the difference in the polar versus equatorial.
If it's imperceptible,
radii
how would we measure it?
Well, there are techniques to do that. I'd be
Right.
glad to show you.
No, I'm good. I'm good on that. I was just
You-
curious.
you
Tell Bella we
asked.
can't confirm it if we can't measure it. We can't if we don't perceive it. We can't measure it. But
We
we
might
can.
as well get to this. You're familiar with the black swan argument, right?
Yes.
What?
Yeah.
I'm.
I've heard.
I'm
of it.
not, man.
Okay.
Enlighten me.
Any explanation for this, or could you actually define what the point of the whole so-called experiment was, the modus tollens?
Well, what it is it's quantum eraser pretending that refraction doesn't happen. So
Okay.
there's that.
Okay.
In that picture, and I'm sure you're familiar with it and you've seen it many times, those rigs, you can see them from bottom up. And despite the fact that the horizon is behind the rigs, and you can clearly see that,
Oh,
shouldn't there be a bulge of earth in front of those rigs hiding the bottom part of it?
Well, let
is
me
this a
show
well-known
you.
example?
That would be your earth curve
Let me just show
horizon,
you.
your
I'll show you.
physical sphere edge that boats fall over, right?
So
Oh.
here is where Quantum Eraser got his citations from. He actually got it from Andrew Thomas Young. Let's see.
Do
Can
you
I
know
ask a
what
question?
terrestrial refraction limit
Can I ask a question?
Kind of a
limit,
complicated
you know
thing,
what
one thing at a time.
limit means?
Okay.
Can I ask a question?
Is it on this topic?
Yeah, it's on the topic of
Oh, I see. Okay.
Let's push the globe. And you
Funny.
know,
Okay.
the map that you're
All right.
using was made up by the Rockefellers
Listen.
and the Rothschilds.
Calm down, Bella.
So I don't.
Bella, all right.
We're gonna have to mute you.
I'm gonna kick her out if she can't stay on topic here. Bella,
Whatever.
Bella, you weren't. I mean, I don't
Love you,
mind
Bella.
if you're here. You weren't part of the original invitation to this. Fine,
Fine,
I don't
I'll leave.
mind.
Bye.
Just
Everyone,
polite.
no emotion. We're all friends here.
Yeah.
Nothing changes. Chillax. We don't need emotion in this.
I mean, it's
Anyway.
not likely that one of us is going to convince the other. We can throw our evidence.
I'm
out
just
there and
curious,
let
man. I've never
everybody
had
else
to-
decide.
A chance to argue with someone who firmly believes it's a globe, you know? So this is fun. I appreciate the time, McTune, and appreciate being on your show. Sorry for our abrasiveness.
oh, I've had much more abrasive.
Okay, that makes me feel better.
Yeah, it's just that there's certain other things that carry relevance, like the space vacuum.
True,
the
true, but we're doing this
Coriolis
very
effect that cannot be proven,
point
except
and
with
point
little
argument
toys like
thing,
green
right?
laser gyroscopes, and all you're proving is angular what? Angular
So the black swan
velocity,
thing
15
was a
degrees per hour.
perspective over the horizon example, wasn't it? Is that what that involved? The black swan cracker?
No, it's the terrestrial refraction limit cannot be beyond 1.22 miles at 1 foot observer height, or the
Okay.
square root of the observer's height.
The
Okay,
celestial
so
what?
it's
The terrestrial refraction limit,
Yeah.
the
So
one that
so-
uses the radius value.
Yeah, so I
and-
think you're missing that. So if
Fourth-
I can go, I'd be glad to go through it. If you
well,
want.
I just wanted to say that
Well, I mean, it's a limit.
right, but
That
do we
means
have a
the
physical horizon
cannot be
All right.
beyond that limit.
or an
You
optical
cannot
horizon?
see the horizon beyond that limit, no matter
So-
what kind of refraction you have, or what
Not-
other shit
not at
you
all.
make up.
That's not at
no.
all the globe claim. That's a completely disingenuous position.
Are we strawmanning you by accident?
Yeah,
Is that so? Do you think we have an optical horizon or a physical horizon?
we have both. But you can't
Okay, explain.
see.
The one that you
can't
say you
see.
can measure from a pre-assumed ball
I-
that you still haven't proven the radius for.
Calm down, man. Stop
Using
making
the
up proof stuff.
radius,
Cracker,
they prove.
chill out, man. Have a drink. Just take a little breath.
Oh no, I'm just saying,
I know. I know what you think. We pick each other's brains for
It's
hours
just-
and hours. I don't know what he
it's just
thinks.
A lot
right?
of logical
All right,
fallacy that I'm not real
glad
sure can be proven.
to present this. All right, so
I've
the
seen
I
all the
already
proof.
showed you the radius of the Earth measurement.
Not telling me something I haven't
You
seen.
did
but
not want to
4,000
talk
miles?
about it, but I'm happy to show that if you want. But so it's not a presumed, it's not a guess. There are measurements of the radius of the Earth.
Right.
So
But
we can
Appeal to
use
authority
those
fallacy.
to
Okay.
plug. I personally measured it myself 4 times. So and it matches. So the radius of the Earth is used when
4,000
we're
miles,
testing
right.
the globe.
so
So hold on. Here is this is your black swan cracker.
yes, sir.
All right. So this first section here is no refraction. You see that? This is the globe
Oh, wait.
presuming no refraction, which never happens.
I like math and cartoons, but I want to see some reality.
Cracker, let him do his thing, man.
You asked. You're the one that brought up black swan. Black swan comes up to this number right here, 1.23 times the square root of the eye height in feet.
Mhm.
You've heard that said before, right, Cracker?
Yes.
All right. That's the
Good job.
no refraction. Okay?
Okay.
Now, we don't claim no refraction. So if you go and do the math with no refraction, that's a
What
strong
kind
man.
of refraction?
Calm down.
Could you describe which one of the differing kinds of refraction this would be?
It would be refraction that causes things to look very chaotic. is
Which
what
one of
they-
the 4 kinds of refraction would it be?
There aren't just 4. I don't need to classify refraction into kinds.
This is good math that works out, but we
All
don't
right,
prove
so now-
math, right?
Here is refraction considered simply.
Mhm.
So when there's simple refraction, when it's very consistent and you don't know the conditions, then you can use an approximation where you multiply the radius of the Earth by 7/6. Right?
Gotcha.
But the black swan is not simple refraction. The
Does
black
this-
swan falls under this section here, variable gradients, or even more nasty complications.
Does this explain how you see an optical and a physical horizon?
You do not see a physical horizon. You can
Or
only
the-
see optical.
But when you see a ship go over an edge, that would be your so-called physical horizon.
That's an
that the
optical
ship is
horizon
going
because you can bring
over.
it back when you zoom in, right? That's optical.
No, nobody's ever
right.
brought back something that's gone over the horizon.
You can
But
zoom into
Well,
it and you can
your
see
eye
that it's
can't see it,
diminishing
But
perspective.
your camera can. So I mean, it's still there. It's
so,
not behind the
Cracker,
curvature.
Let me be clear, Cracker. You cannot see physical. You can only see optical.
So I can see things that I can't see.
And
Well,
when
that's-
the
he's right.
when the photons travel through the air,
Your odds
just
influence.
like when it
Okay,
goes
okay,
through
good.
the glasses that I'm wearing here, it refracts when it changes in medium. And the air
Fair
has
enough.
differing index of refraction. So-
I agree that there are things like weather, humidity.
So when you rise up and the horizon appears to meet your eye level, that's the
It never rises to eye level, but that's a different topic. I'm glad to cover if we get to it.
so
Seems to happen every other time I've seen it.
well. Wait, so we're seeing that the as you rise up, the horizon seems to recede from you.
It lowers.
That's never been observed, has it?
As you go up in elevation, the edge of the horizon goes lower. But
But
I
we
mean,
have
do you want to
high
change
evolution.
topics, or do you want to finish the black swan claims?
This is all kind of the same topic, isn't it? Optical and physical horizon still is the general category, I think, right?
Well, his topic.
I think
was
a
black swan.
horizon that is beyond 9 miles, whether there is no refraction in the world that could possibly explain.
Oh,
that.
I'd love to
Refraction's like
see
gravity, man.
I'd love to see your math.
And there's
supporting
no
So, Cracker,
Earth
you just made. Hold on.
curvature.
You
Let
just
me
made a
finish,
faith-
please.
you just made a
There's
faith
no
claim.
Earth curvature in front of the oil rig. There's none.
You just made
You can
a
see
faith
a
claim.
boat there. You can see the base of it. You can see the concrete bases of the rigs.
And where did you
There
do
is
the
no Earth
analysis?
curvature hiding that.
Do you have the analysis that you can show me then? That you
You've
did?
seen the picture a million times.
I
Well-
have, and it's drastic quantities of refraction because we know that those
Because
cranes
that's the only
are
excuse
not
you have.
bending.
Hey,
Those
calm down, man.
Cranes are not actually bendy; they're actually straight. So when
And
you
you're
look at
using
that,
a presupposed
and you
radius that you
see-
haven't even proved.
True, but
I already
let him
showed you
go.
the radius measurements.
4,000
All right, I'll go
miles,
back.
that's
No,
what was
you
told.
showed
I
me
got you.
numbers
Here
and
you go. All
pictures
right.
and
Here is
what?
actual radius measurements done
Uh-huh.
by people that know what they're doing.
But the base
If you
measurement,
disagree,
Oh, at home.
the door is wide open for you to show that it's wrong.
isn't this an astronomical unit? So we're using the measure of the Earth to base the size of everything else, isn't that?
No, this is measuring the radius of the Earth. That's what this particular, these 6 different ones in here were specifically
4,000 miles.
to measure the radius of the Earth. 6,377 kilometers.
Equals to be about what 4,000 miles, something like that.
Yeah,
cross
just under
radius.
3959 is the
Right.
number that is most commonly used.
But these are all given to us, and they observed they found these things in a textbook, and we're using the compartmentalized versions of these to prove the basic complex version of it.
Yeah,
Us,
and
it
that's
doesn't
appeal
prove-
to authority. Like no one knows.
This
These-
is
That
not an
doesn't-
we
appeal to
really know
authority.
if these numbers are
And-
true.
By itself,
And
is
let me
right.
ask you another
And-
question.
and
How
hold on.
exactly do you get a radius of an imperfect sphere? I'd love to hear that.
Are you going to interrupt me when I start answering?
Probably. I'm sorry.
It is a geoid. It is not, like you said, it is not perfect. It is generally a different
So that means
equatorial.
that you would have a
Let him
various
finish, Cracker.
radius number. That's what I'm asking.
Let him
Cracker,
finish his
I'm
thing.
just going to have to kick you out if you can't just have the respect to let me finish a sentence answering the specific question that you wanted me to answer.
Yes, sir. I think we're good.
Sure, go right ahead.
We're fine.
All right. They are differing in equatorial and polar radii. And all of these measurements here, these 6 measurements, all show that there's a difference.
You do. That math is solid, but that doesn't mark how the thing we live on to me. Just saying.
So
I know to you.
But when you say that the radius is presumed, it's not, it's measured. These are the radius measurements that you can use to test whether or not the observations match or don't.
That's also the way we calculate curvature to see that there is no observable curvature as it would have to be for a sphere about 8,000 miles across, right?
Wrong, but I'd love to see those particular observations too. So we've got the radius. If you disagree, I would love to see the measurements that you've done.
Nope.
Or the analysis of these, pointing out the errors.
Doesn't really require.
The cracker. Let's do it this way. These are the passed down measurements that the textbooks tell us, right? That's what he's saying. That's provable, isolatable by itself, singular provable, mathematical. Okay, that's by itself, right? That's correct. That's what they tell us. We don't agree, but what's showing there is true.
And you can test it.
Math, right? Math works out. But if you start an equation with...
And if you're going to test it, you have to test it correctly. You can't test a straw man. You have to test it correctly, right? So you cannot test it by looking at something with refraction and pretending that there's no refraction, because that's wrong. That's a straw man.
You can't look at it and pretend there's no perspective either.
You're right, and I can easily calculate perspective. Right. I know how to do that.
Is this how we're going to say that the observable curvature? That's why, because of refraction, we can't observe
perspective
curvature?
Left out of your math.
Perspective is included in my math. I don't know what you're talking
about. So is this how you're going to say we can't see measurable curvature because of this? That's why it's refraction, or what?
This isn't refraction. This is the radius of the Earth, right? So
right.
Then this is refraction. This is the page here by Andrew Thomas Young, written by he's at St. Cloud, or not St. Cloud, San Diego State University. So he talks at length here in this nasty complications part why you would see all sorts of differing effects.
Weather, humidity.
Let him go, man.
Yeah. And the time when the effects are most dramatic is late in the day, over water, when it's been sunny, which is exactly what the supposed black swan was. It was late in the day, it was sunny, it was over water at low elevation. That is the most dramatic time and position that you will see refraction effects. So if you are not willing to include whatever is necessary to control for those confounding variables, then that particular observation is of very low quality. You would want to get to a higher elevation away from the dramatic effects of refraction so that it's minimized. It's still not gone, but it's easier to take into account.
Does refraction affect the Earth's curvature in our observable way? If we can't measure curvature 8 inches per mile squared, depending on how far away you are, shouldn't it curve beyond the physical horizon from the radius of the Earth?
I have never once seen a too far measurement or a too far observation that didn't match the actual correct prediction of the globe.
Wait.
Never once.
Can we do an example there? What do you mean? So if someone sees an object too far that should be behind curvature, and then this math adds in refraction to see, well, actually, it's exactly where it is, and you just can't see it there?
Is that just an excuse? That's what I'm saying.
It's the model. If you want to test something other than the model,
we don't live on a model.
Yeah, but you want to test. Well, then don't test the model. If you're going to say we see too far, you've just brought up the model.
Right. We're using the model as an example.
So Cracker, if you're going to say we don't live on the model, don't refer to the model. And then when I talk about the model, you're like, oh, we don't live on. You brought up the model, not me. All right.
True.
So
I'm
happy to test what the globe predicts.
Yeah, it predicts. It doesn't prove.
Well, hold on. I want to walk an example of this. I've never heard of this. So let's do the one where they saw the skyline across Lake Erie on the news. What was that one, Cracker? From a clear across Lake, they saw the Chicago skyline. Right.
Oh, the one where the light bent over the Earth curve.
Right. Let's see. Oh, maybe you got it. You got it.
The base of the buildings.
Yeah. So let's use this as an example and then take me through the math that makes it actually correct, please.
Let's see. I forget the name
Math.
of the guy.
Whoops.
Cracker don't like math.
We do. He's actually really good at math, man.
Cracker, are you any good at math for real? Come on.
We're nice. We don't talk down to you, man. We're not retarded. We're not stupid. We're very
I'm
good.
messing with him.
Okay, I'm sorry. I couldn't tell, man. We appreciate it.
All right.
So
Let me
I'm
What was
just
it?
waiting for some proof of a glow.
He's not gonna bring you proof of the globe, man. No one can.
well,
I
proof
just
the,
don't see it.
the claims of proof is a pseudoscience position. Their science is
actually,
always science is always open.
Experimentation that is repeatable.
Right. But
Prove-
Science
and
is
proves
always
a
open.
hypothesis with
Always
a cause
open.
and effect relationship that is naturally observed in nature is science, and it does prove things.
It does not
Oh.
actually.
well, math.
Okay, an
anything that's
experiment doesn't prove
if it's
things.
proven, it's no longer open to be disproven. So it is then no longer a topic of science because science is always falsifiable.
Isn't that the
Well,
truth?
we had the right.
Agree on that. So the Chicago skyline. Let's get the distance. It was. They said on the news that it was an ocular illusion. I think, or some crazy thing.
Yeah,
but-
the news guy said it was a mirage. That's
Right.
incorrect.
Right.
It's I have the
Zooming.
so there. This is the photo from Joshua Nowicki right there.
Like, look at that nice flat horizon. Isn't that beautiful?
It is.
And it's how far away?
What,
I'm looking
54
for that.
miles?
And
Do you know that? You have it pulled up there?
54
You're quick.
miles.
and what was the
60
elevation?
miles away. It's taking 60 miles away from, let's see. I don't know where the vantage point, I guess. We don't know. Let's see.
I thought he took it from a pier on the beach.
Did
He
Rob
took
Skiba
it
do
from-
this?
He took it from the top of the
Was
hill.
Rob Skiba the one that did this? No, he
Skiba
went
did
and
not
proved
take.
it.
This is Joshua Nowicki. Skiba went across the water there,
Gotcha.
and it didn't really make sense what he was doing. But let's see. I have. Let's see.
Poor guy.
The actual.
You could almost lay a ruler on that.
So, all right, there it is. Here is the elevation analysis right here. You see that?
Yeah, what's elevation?
So this was, I think, 108 feet above the water.
They took that from 108 feet above?
Yep,
100.
right there. See this where it says untitled place mark. That's where Nowicki was. He was in a. They did an interview with him later, and he brought the news reporter up to the spot where he took it from. So some people
Thank you.
have done the analysis and found the spot that he was at.
Okay.
There you go. You see elevation, gain loss, 186 feet. See that down there?
But isn't he looking at, oh, this is just the vantage point. We're not doing the perspective that he saw across the water yet.
So elevation, gain loss, 186 feet. So from the top of the hill to the water, 186 feet. Right there. Elevation, gain
And 60
loss.
miles. Right.
So we can go to the Walter Bislin Advanced Earth Curve Calculator.
Mhm. 50 miles should have what?
I think it was 54 miles, and we got to go from these metric units to freedom units. What was it? 150, 186. Target distance. And let's go with, there you go. So hidden,
Okay.
540 feet should be hidden. And how tall is the Willis Tower?
That's the thing. You can see the entire skyline. and
Right.
things shrink as they go into the distance.
I've never seen the math that makes it actually.
Yeah, I've
right.
never seen anything
So-
that legitimizes that picture.
Right.
So there
Ever.
you go.
I've never seen anyone's
1450.
excuse.
So here is, you ready to see the globe prediction?
Well,
Look at that. The globe predicts that you
Prediction.
should see a good section of it, more than half of it.
where was the curvature?
Yeah, but we're
We should be
seeing the
where is it?
entire Chicago skyline. All of those buildings are not that tall.
Wait, hold on,
I've
go back
been
to
to
that.
That's the
Chicago.
ent-
Where is Lakeshore Drive?
Can we go back to that calculation real
Hold
quick?
on. He is claiming you see all of the skyline. Where is Lakeshore
Well,
Drive?
How many buildings do you see there? And you know that things shrink in the distance and they disappear from bottom up, whether it's on a
Oh,
flat surface or a
so you've
spherical
claimed,
surface.
but not.
No, that's not a
shown
claim. That
evidence
is
for
a fact, and you know it.
We're getting
No,
caught
it's
up in
not a
details,
fact.
Cracker.
That's a belief.
So you
Until
think
you've
that things
shown-
don't
until you've
disappear
shown-
on a flat surface
Until
from
you've
the
shown
bottom
the
up.
plausible mechanism that causes something to disappear, to be obstructed bottom up on a flat surface, then it's just a claim.
Well,
not
a
a
belief
me,
claim.
Sorry.
So now there is
It's
no
called diminishing perspective.
yeah, everything shrinks as it gets farther away. That's perspective.
Yeah, there you go. So how
Everything
many
shrinks.
buildings do you see in that picture?
Well, not enough.
How many of
because-
them are
because
above?
some of them
How many
some
of them are taller
missing.
than 540 feet?
There are some missing.
How many of them are
What do you mean?
smaller than
Lakeshore Drive is
540
missing.
feet?
Lakeshore
So the
Drive is missing. Where is
bottom
Navy
up.
Pier? I don't see Navy Pier. That's a pretty
I'm not
big
familiar with
structure.
Is that
Chicago,
the lower version? So we're missing the bottom, like 10% ish.
Yeah,
Maybe?
you're missing a large portion of it.
that
So
means
where
every
is-
one of those buildings would have
Wait,
to
hold on.
be
Why do we
over
think that is?
540 feet. That's 54 stories.
Why would the globe model say that is? That we're missing the bottom 10% ish, sir.
10% what?
Well, if we're missing the bottom portion of it,
Yeah,
what's the reason for that? Is it the horizon, the curve, the
yeah,
distance?
the obstruction. There's something in the way. The light gets blocked. It can't get there.
But it's really just the waves in the water, right? It's as far as you can see. If you zoom all the way in, you'll see everything is correctly.
Zoom does not change how much you see. It never
does.
modifies the amount of bottom up
does.
obstruction.
I have to disagree with
And it modifies
I've-
the distortion, right? If you look at a
No. The bottom up obstruction is never modified by zoom. It's always the same.
So that's the sphere edge that things disappear over.
hold on, I don't think that's true, man. If you zoom in, you can see the bottom stories that are clearly obstructed from our regular view. And if you zoom in on a
That
multi-story
has
building, the lower floors
never-
look jumbled together. And if you zoom in, they appear equidistant again. Same
That
thing with
has
boats on the
never
horizon.
happened. That is, I love hearing flat earthers say that, and then I ask them for the video, and it never comes. So what you have seen is you have seen something that is not over the horizon, that's too small to see when you zoom out. But when
Or
you
too small
zoom
to
in,
use your
that's big
eyes.
enough. But you've never
Well, this
seen
is interesting.
anything ever get obstructed bottom up by the horizon, and then zoom brings it back. That's never happened.
Oh, well, hold on. I think we've seen that. Let's see. If I can find
So
it.
if it's not disappearing over a physical sphere edge, what's pulling it down? Gravity?
Yes.
That's just, come on.
Different topic. Definitely gravity pulls it down.
That was a cheap shot. Let's see. I mean, we've seen hundreds of these. The bottom is
Yeah, I've
definitely
seen quite a few.
brought back into clear view via the zoom that you can't see from your eyes, and you can receive the missing bottom
will
portion.
be
that was
if you have that video, you'll be the first one.
All
But the
right, well,
horizon is supposed to be the sphere edge that things disappear over.
Yeah. And never once has Zoom changed how much has been obstructed.
interesting argument. I'm glad we're doing this, man. See? That's,
So you're saying that things don't disappear over the sphere edge.
Not at all. I didn't say that at all.
well, he's just saying that
Okay,
it's
so
never,
then you're
I
saying
said
that it
we
is
are
a
looking
physical
right
thing
now
that things
at
disappear
an
over.
example of things that have been obstructed bottom up, partially. And no amount of Zoom
But that
will
happens on a
unobstruct it.
flat surface.
No, it
also.
doesn't. There's nothing
Yes,
in the
it
way.
does.
There's no plausible mechanism to explain it.
well, hold on. Let's see. Let's try this one. Ready?
So we've got Brian Peck
sure.
says that over 70 buildings in Chicago are over 540 feet tall.
Okay.
Don't know if that's true. That's just an audience member saying that.
Do you want to switch sharing real quick?
Oh, yeah. right, go ahead.
Let's see this one. I'm sure you're familiar with David Weiss. I'm sure you don't like him or what. Have you ever done with on an
He
interview
is
with
so
him?
scared of me.
Is he? He's not scared of anyone, sir. That's
he's
lies.
so scared of me.
Yeah, I saw him do the Professor Dave, and he didn't come out looking too good on that anger,
No.
emotional jab fest.
No, Durf did not look very good in that one.
Let's see.
Face. It can't block my whole face. But my wave was halfway to you. Look, it's blocking half of my face.
So this is the lower part,
Because
right?
I'm smaller, but the wave is
Oh my
bigger.
gosh, he has no idea.
And it's how perspective
So
works.
hurt Eric
we
so
can give him a
much
minute.
to hear the,
So this
the
boat, there's
nonsense.
no boat on the horizon here.
So hold on
And
right
as
now. So we can't see it with our eyes, right? No boat on the horizon.
That's like I said. It's exactly what I said. It's too small to see. It's not obstructed bottom up. It's too small to see. So you're gonna zoom in, you'll see it.
Oh, I see.
But
I
it's
see.
not
Okay.
obstructed. It's not over the. It's not over the horizon. It hasn't been obstructed by the horizon yet.
But it does disappear bottom up,
Okay.
and it does restore what it
And so I'm
was
going to zoom all the way
unable
No,
for
it
you to
doesn't.
see.
It
Now
doesn't
that's-
appear bottom up.
Now
It
watch,
just
it's
gets
gonna
bigger and smaller. That's it.
It doesn't disappear bottom up.
No, it doesn't. It just gets
Well, hold
smaller.
on.
And so I'm going to zoom
But
all the way
how-
to the sailboat.
Wait,
Now
wait,
I'm
30
actually
seconds.
so
The Earth's
sailboat just flew away.
curvature
It'll be the same thing. Now watch, it's going to disappear from the bottom
calculator.
up.
It's
Little
not
waves
disappearing from the bottom up. He says it, but it's not. And you listened to him and you let him hypnotize
did.
you by
This-
claiming that,
My
and
claim,
you believed it.
I did not make any claims here.
But this is
I'm just trying
repeatable
to see the legitimization.
and
of yours.
verifiable.
It's not repeatable because not once, exactly 0 times, has something been obstructed bottom up by the horizon, and then Zoom brought it back.
I see his argument there. So it's even though we can't see it, it's technically not disappearing. It's still in exactly the same position, regardless of whether we can perceive it or not. And then we use the apparatus to bring it back in, and I see what you're saying.
All you've done is show that Zoom makes things bigger. That's all it does.
Well, I thought the point of this one was that they had the physical horizon claim that the boats were over the horizon from way, way, way back. And this was to disprove that to see, well, no, we can still see it. If it disappears over a hallway that's curved, you can't zoom in and bring it back. If you can't see it on the flat ocean, but you zoom all the way in, you can bring it back.
Show
That,
me
I think, was
something
this-
obstructed bottom up
But
that
Well,
gets
I'm gonna-
unobstructed bottom up.
this
with Zoom.
happens on both a spherical and a flat surface.
See, his
This
argument
does
is
not
very
prove
technical,
It
dude.
actually
He's
doesn't
right.
happen.
Gotcha.
It doesn't happen. It happens on both.
Well, no, his technical explanation would be correct,
Well,
but
technical explanation doesn't really
sure it doesn't, dude. But relax.
separate
I like
either
this kid.
one. That's all I'm saying.
Oh, you were
Look
sharing,
at that,
right?
people.
You know,
He called me
it's-
kid. He knows I'm 13.
I think I'm the youngest person in the whole group. So I mean, I'm 35. I think I hang out with 50-year-olds. So I'm in the right boat, right?
Dude, I'm 13. Seriously. Just, shh. 13.
There you go. You can put that.
So
All
I
right.
don't know.
I have
all of that math requires a radius value that still
Yeah, which I already
Math
showed.
is
hasn't
math
had
is
any
math, man.
legitimization. Math
you
is
start
math.
an equation with a variable of dick.
But this
and you
is
end
the
up
whole
with-
thing.
You still have nothing. You haven't proved anything. That's all I'll tell
At
you.
one, listen, no matter what kind of refraction or bullshit you bring up or make as an excuse in that equation, when you're seeing that black swan argument, you cannot see that horizon past 1.22 miles at 1 foot observer height.
I mean,
No
you
matter
just-
what
you're just,
excuse.
I've never
you're
heard
just
of that one.
pretending again that there's no
No, I am
refraction there.
not pretending.
But there's
And they're
there's
seeing
refraction.
the horizon beyond 10 miles. There is no math that can make the
Only if there's
excuse
no
for that.
refraction. So, all right.
No,
Here is-
Refraction's like
there is
gravity,
no
cracker.
amount of refraction.
Hey,
Show me the
gravity's like
math
cracker.
that would
It's the magic
legitimize
beam
that.
that can whip out, dude.
I'm
Come on,
out.
don't worry about it.
No, I really want
I'm
to see
glad-
the math
I'll-
that
I'll-
legitimizes
Uh-oh.
that amount of
Glad to
refraction.
show you the math. All right, here you go.
And then tell me what kind of
Here,
refraction
hold
it is.
hold
There
on.
are differing kinds
Here
of
is the
refraction.
formula, number 4. See that formula number 4 there? That is the formula that
Okay,
predicts.
show me the numbers in it. Show me the numbers.
All right, here you go. Here's the
And
numbers.
does this require a radius value that
Of
you have yet
course.
to
Well, no,
Yes.
no. This was our curve calculator. that
And
we
how do you
plugged
get
in
the
all
radius of an oblate spheroid? None of these questions.
Stop
have been
backtracking,
answered.
man.
I keep
Relax. We
answering
assume
them.
the radius. We assume the
No,
radius to do
the
this
radius
example, man.
was physically measured. Physically
Fine.
measured.
Fine, but we had the number that we started with that we all agreed upon. We can't go back on that now, man.
All right, here's the numbers you asked for.
Okay,
Right.
then
It's the
Wait,
application
I
of that
wanna-
formula.
I wanted to see
showed.
the drop of curvature, the measured curvature drop that we should see. I don't see that. Is it
because
not labeled
apparently
for
I'm
me,
not
or am I
gonna
can't
get
read?
any
The
legitimate
dip- the
answers
dip
to
of the
these
horizon?
questions.
1,300 feet. Is that what it is?
So
How can you have a horizon that is 10 miles past where it's supposed to be?
Let's
Right,
do
okay,
modular
here it is.
arguments,
There
man.
And
it
that
is,
thing
right there,
limit means
there.
limits.
Well,
right there.
I
Here's
mean, but
number
when we-
4. Equation
right,
number
right.
4.
Refraction does not overcome
Kraken,
that.
are you
When-
just sea lining? You're like, you ask a question,
Well,
they give
where's
you
the
the answer, and you
numbers
ask
that
it
you're
again.
using in this to
Oh,
legitimize
right,
this?
right here.
Dude,
Here you go. Right there.
I just
right
wanna
there, on the screen.
So is this the saying that there should be 1,300
This
feet
one.
of drop? Is that 540? Okay, 540 feet.
540
hidden.
hidden.
Oh
And
no,
you
I'm
said
talking
this-
about the black swan. I'm
Here
not
it
talking
is.
about
Right,
the
right.
Right here.
Chicago picture.
And we said
You
the
see
skyline
this?
was how
You see
how
this?
high?
Hidden height, right here. H
Right,
of
right.
H. That's that number. 540 comes out of this formula when you plug in the numbers. Right? You got R as
Right.
radius. You got S.
Where is
the
this radius
distance.
coming from?
Dude,
It's the sea lining is amazing. There you go. It comes from here. The transcontinental triangulation in the American arc of the parallel.
So again,
is
how
one
do you
of
get
many,
a radius of a spheroid?
which is
Cracker,
one of
man.
many
It's a-
times.
they
All
can't, but relax.
Right here. There is what you do is you get
Then
two radii out of it. You get
This
an
proves
equatorial.
nothing to me.
I
No,
don't,
no,
I
dude.
don't care that you don't get it.
Fair
Right?
enough.
I'm not here to
I mean, we're
convince you.
talking about
I'm
math
here
and
to
cartoons.
convince-
We're not talking about
I'm here to
reality.
convince the people that might be watching that I know what I'm
Right.
talking about and that you are just making up crap and denying things.
Well,
So-
you know some
so-
abstract math that
so
is
here is-
equation.
Yeah, and I mean, it's a lovely
So here you go.
cartoon model, but
Here is
you have no
6'3".
proof of this.
You asked how do you do an oblate spheroid? How do you measure the radii? There are two. You've got one, 6377912 meters. That is larger. That's the equatorial radius. You got 6356309. That's the polar radius. Right? Now you can read this entire book if you want and find all the errors in it if you want.
Math doesn't have errors, but math doesn't
This
prove
is a
our world. That's all I'm
measurement.
saying. It is
A
but
measurement
it's-
that people in the field for years measuring the earth, physically out in the field measuring it.
We know that, right?
Okay.
We know the
So,
radius. We know
all right,
how
so-
far continents are.
So no more sea lining. I've shown you the radius of the earth. If this is at mctoon.net/r. You can just go look it up yourself and find it there. There's 6 different ones here. There's many more than this.
So
Now, then you specifically asked for how is it done? Here's the formula. S
and the
is
height of the building
distance.
was. What did
S
chat
is
say
the
again?
distance between the observer and the target. H0 is the height. HO is the eye height of the observer. And R, the radius, you multiply by the coefficient of refraction. At sea level, it's suggesting 0.17.
And
but
How
it
high did they
depends.
say the skyline was?
So
The
hidden
chat
is
threw it out, but I
540.
forgot.
But we can look right here. We can see that there are buildings missing, and you cannot see Lakeshore Drive.
So are we saying this is exactly missing 540 feet from the calculation?
Not
we just
exactly. We don't know
But-
the exact coefficient
That's
of refraction.
considering that his coefficient
put? Close
of
enough to prove the
refraction-
globe, right? For him.
is
That's what I'm trying to
correct.
say.
Yeah,
It's-
it's
You're testing
considering-
the hypothesis
well,
of the
is
globe,
it?
and the globe is confirmed.
We're
So that's
testing
how
the
sci-
math.
that's how you
of
do the
globe.
science.
That
That's
was
how you do
math.
science. You have a
Obviously, that's
hypothesis.
For
confirmed.
sure. For sure.
You compute the consequences of that hypothesis, and then you test them. So the hypothesis: the Earth is a sphere with a certain radius, or an oblate spheroid with multiple radii. But for this particular one, we can approximate it just fine with a single radius that's in there for the average of the two.
So, Cracker, they
And-
use some gravity math to show that it actually is exactly where it is, no matter what you see.
Oh, there's no gravity in this particular.
I know.
calculation.
Sorry.
Well, there's no
So,
gravity
wait, Nick-
really at all. But
Do you prefer to have cordial or do you like heated debates? Does that get more views? I'm
I
trying
always-
to figure out.
I always prefer the cordial ones. I know
Yeah.
what gets more views, but I
Okay.
don't target that. I don't try for that.
I'm just curious. You know, people do
I
their own
just don't
thing.
really feel comfortable speaking freely in a debate that's being controlled. You know,
Why? We knew it was controlled going in, man. Why are you so worried? We're all friends,
not
man.
worried.
At the end of
It's
this,
just that-
everything's fine.
I'm not allowed to question anything.
I've never spoken to a glober who was as let's see, as well researched in the HUI, the textbook science that proves nothing. But I mean, yeah, what I meant to say is I'm impressed with you. So thank you for the time. I've never seen someone who's held to this belief so hard.
It's not a belief. I mean, this is all empirical.
Well, true. Well, I'm not going to argue that one. Are we doing back to our examples to try and prove flat Earth again?
So, all right, let's see if we got. Let me show you this one. Just
am I sharing? No.
To round up. No, this is mine.
Okay.
So I'll do this quick. So I've never, like I said, I've never seen zoom change how much is obstructed. So this is a P1000. You can see the camera, the ship right there in the center. So there's a ship in the center, and there's a ship farther off where you can just see the top of it. All right, you see that you do not see the deck of the ship on the left one. Right? You just see the tall things sticking up, and you see the back part of there. And now when he zooms in, you still don't see the deck of the ship on the left. Pans a little bit there to the left. He zooms all the way in. It doesn't actually change how much is obstructed. No matter how far he zooms, the same amount of obstruction.
This is
there.
relatively close, though, right?
No, this is a P1000 zoomed in all the way.
Oh, but where did it start out as?
Right
is
here.
It visible to the eye? Or no?
It is visible to the eye. It's in the center.
I see.
You can see that the rock sticking out of the water, a little shorter rock, and then a small one, small thing. That is the ship. We'll zoom into the ship. There it is. You could see it with the naked eye. And zooming didn't change how much was hidden.
Right.
Right?
The motion of the ocean, the waves on the bottom will always be an obstruction no matter what we live on, I think.
But
perspective is perspective.
But he's higher than the waves, so the amount of obstruction that you can get from the wave is very, very small.
Yeah, and this could be different on different days, and you could see farther
atmospheric
on different
for sure.
days.
Exactly.
You could have different types of refraction on different days,
sure.
and this proves absolutely nothing.
Although it is neat. I like that example.
What is causing?
It's interesting to look at, and I've seen all of this before.
What is the
but I'm
plausible
just
mechanism?
not really impressed with this.
We're not giving you a grade at the end of this, Cracker. It's okay.
I mean,
What's the plausible
just kind of
mechanism?
following along and watching, but I'm
for us
not very. It's just not
what
real
is
evidence.
the cause? What's the plausible mechanism that's making the bottom of that ship be obstructed?
The motion of the waves. It's only as low as the highest wave could crest in that time frame, in that distance.
I mean, we can do the math on that. How high do you think these waves are? Because
I have no idea.
Because that ship is not a small ship.
You can factor in every condition, weather, humidity, everything into this, and you think you can do the math.
Well, I was taking a guess as to why we can't see it. I don't actually know why we can't see it. What do you think, Cracker?
Well, it's because of just like what I said. It's how do you get these factors and put them into an equation?
Is there a distance we could be where we would see the bottom? Is it just we're too far away? If we moved halfway up, would we see more of the bottom? Maybe half of the bottom.
I don't know, because the weather changes. This could be one day, it could be under this condition.
Right.
See it under this.
But if we assume there's always a lower portion that's obscured, no matter how far away we look and how far we zoom in,
do it 100 days, compare it, and we can.
What do we think is always that lower obscurity? What do we think that is? It's the same as in on water as in land, right?
It could be several factors. It could be humidity. It could be weather. It could be the sunlight.
Well, if we did the same thing on the desert, would we have the same issue?
It could be, there's a lot of things.
I'm thinking waves. That's why I'm like, do we think if we did it on like a desert, would it have the same problem? I think we might. So then, Mr. McToon, what's your answer for what we don't see the bottom? Oh, we got more.
I don't know on flat Earth. I've never heard a plausible mechanism for flat Earth.
We wouldn't expect you to answer flat Earth.
I keep asking, but nobody ever gives me any answer. So I've got. Let me get the right. There we go. Oh, you're not centered. There it is. Here I drew a picture here. We've got the observer over here, right up on some. He's not real high, but he's above the water there, higher than the waves for sure, because his feet are not wet. And then we've got the boat over here on this side. Now, so the boat, the waves nearest the boat are the ones that would be blocking it the most because he's way higher than any of the waves on this side. So his line of sight from where he is to the nearest wave that could potentially obstruct it, that'd be the waves closest to it. I'll draw a little line there. Now we can do this without any math, right? I'm just drawing pictures and we could pull out a protractor and measure the angles if we wanted.
Right.
So right there, we still have this amount of the ship that would be visible, even if this wave here, which the wave certainly isn't higher than the ship because you definitely see them crashing over the ship. The closest wave to the ship is the one that's going to be able to block it. These here, because the camera's too high. The wave is not in front of the camera.
So it's the closest, not the highest?
Well, if the camera was low, then the near ones could obstruct the camera. But because the camera is above the water, the guy's feet are not wet, and it's not 6 foot high waves. Right? These close ones aren't tall enough to block it. So you're right. You know, your thumb can block everything, right? But it's got to be in the right position. It can't just be somewhere. It has to be in the right spot. So there you go.
Well,
I got a new notebook today, by the way.
I haven't written on a notebook since I got a computer, I got to say.
Yeah. Brand new. I had to go to Office Depot to buy an envelope.
Like poster board and markers too while you're at it. I never see those again.
Oh, I love whiteboards. I have a bunch of whiteboards at work.
Are we doing another show and tell for us? Or?
So, all right. So let me just, maybe you could come back to me and you could be the first one. What is the mechanism that causes the bottom up obstruction, Cracker? And maybe is there some sort of way that we can test the hypothesis?
Well, what about that model? Wouldn't apply to a flat
It's like
Earth
I
model?
said, you can't do it in a single instance of time.
On that example, wouldn't that work on the flat Earth
And
model
just
too?
apply
Above the
some
time?
math to it and get an answer for that. You would have to do it over several days. You would have to consider the weather conditions, the humidity, the temperature, and everything else, the time of day, the position of the sun. And then
how does the position of the sun
at least
involve in that?
Okay,
Now we're arguing refraction. Oh boy.
Oh, here we go with refraction.
So we're
I
arguing refraction.
mean,
The example he just drew out on his nice notepaper, doesn't that work? What about that wouldn't work on the flat Earth model?
that's
What about it
exactly
wouldn't
what
work?
I'm saying.
Yeah.
What does this prove about a globe Earth model? This can be done on
This is
either.
testing flat Earth hypothesis. That's all what I'm doing.
Oh, I see.
And I'm asking, I keep asking, what's causing the bottom up obstruction over water? And I never get an answer for flat Earth. Because the waves
Distance.
wouldn't do it. I just showed you, unless you want to draw something differently. But this is an approximation of what we just looked at.
The limits of ocular perception, that's what I think it is. So with too far away, the angles has to recede into towards the middle, and that's why you lose some on the bottom, I think. Angular perspective.
But perspective makes things get smaller consistently. Everything gets smaller at the same time. So the bottom gets smaller at the same time as the middle gets smaller at the same time as the top gets smaller. So why arbitrarily would the bottom, which didn't get any smaller than the top, not be seen? That doesn't make sense.
Well, that's why I'd want to repeat it, I think, on a desert before I ventured another guess. I'm thinking the water, the motion of the water, anything moving, I think, has a lower obstruction. That's my final guess. Because I really don't know.
All right.
But that's interesting.
Hold on a second. I've got a couple. I have what do we have? 500 people in the live chat here. I have.
Everyone, what we got for questions? Nothing.
I've got some questions for you from the live chat, if you don't mind.
Sure.
Many Karen, who lives in Israel, says, was the Earth flat 100 years ago? Can you go back and measure it yourself? No. Well, that's a problem, huh? Oh, he's referring back to the movement
Aristophanes.
of the stars.
Are we referencing Aristophanes' example that apparently
No,
was 100 years?
it was the movement of the stars that have
Oh,
been
the
documented
Polaris
for
thing?
hundreds of years. Yes.
Yeah.
So why do the stars move on the globe Earth model?
Why do they move?
Or no.
Yeah, is it because
Why do the
of
constellations stay the
axial
same is my
rotation,
question.
Or
So the constellations move slightly, and over time they've been documented.
no, I'm talking
to move.
over a
So
24-hour period. Does the Earth rotate?
No,
why
over
do
a
they
year.
spin? So there we got 2 questions. Right? Shane, I'll answer yours. Yours is why do they spin?
No, why do they perfectly like why do the constellations stay in exactly the same place year over year on
They don't.
the globe model?
They move slightly. And the reason why they move slightly is because all the stars are off some large distances away from each other, and they're moving relative to each other. But
Do you have any proof of how the
Let him
distances
talk,
to
man.
the stars?
Stop with the proofs, man. Let him finish.
Well, I mean, I'm just asking.
I wasn't done. Come on. Let me finish.
That's a begging the question fallacy.
It is, but
Do
you can't
have
say that
proof
till
of
the
the
end.
distances because it wouldn't make anything else work.
Yeah, and
True,
we
but,
could get into that, and it's been done. But let me first finish my explanation that was asked. So they're very far away. They are moving in relation to each other, but because the distances are so large, the distance when they do move, they move very slightly, but it is enough to measure.
Right. That's how we get the ages and the zodiac. That's how it follows the sun a little bit slower, so that every epoch changes, and then the season. Like
the zodiac is because the Earth's rotation isn't exactly 24 hours. So when you are on one side of the Earth of the sun in your orbit, you're facing one direction for day and the other direction for night. And at night you can see the stars towards the night side. Come around to the other side when it's daytime now, 6 months later, you don't get to see those stars. Instead, you see the stars the other direction.
So how come the bottom of the globe doesn't have its own zodiac?
They do.
But there's only one zodiac.
We do not. Well, the zodiac are mostly near the celestial equator, so you can see them most of the Earth, but you cannot see the Southern Cross in a large portion of the northern hemisphere.
The constellation, shouldn't they have the top of the ball this is the whole sky, right? This is one like zodiac. Shouldn't there be a whole nother one on bottom?
There is. They do not see the Little Dipper in southern Australia. Ursa Minor. It's a constellation. They do not see it in southern Australia.
The zodiac is like a dome, a sphere. Everything above us, right? Everything we see is that should be a half of a circle, right? Our optical viewable sky.
It's a full celestial sphere, all directions. It's a sphere.
I see what you're saying. Okay.
And the zodiac are generally near the equator, the celestial equator. Sorry. And so if you ever get a Skyview app on your phone, there it is, Skyview Lite right there. If you ever run that on your phone, let's see here.
This is the one that
you can look up and you can see the stars around you. And if you're like this mostly, you can see the zodiac. But if you look at the North Star is part of Ursa Minor, a constellation that is not part of the zodiac and is not visible in the southern hemisphere for much of it. And we also don't see in the northern hemisphere the Southern Cross very much. Some parts of it we can because we're far enough south, but I think in Minnesota, I don't think we can ever see the Southern Cross in Minnesota where I live.
I know Eric Dubé's explanation for it, but I know for me that didn't sell me, so I'm not going to bring it up.
Good.
What do you think about the Southern Stars cracker? Because that one kind of still vexes me. I think Dubé does this crazy mirror thing, which I don't get, right? Like this thing. I was like,
he just makes a hypothesis is all that. For the most part, all of the claimed proofs that
any
flat earthers
rotation
present are
of
just
any
hypotheses.
stars would require the proof of Coriolis effect.
Well, hold on. Oh, there we go. I remember watching this and going, I don't
It would
understand.
require that the Earth has axial rotation.
Yeah, which it does.
Okay, so
Let me leave that one alone then.
so where is the Coriolis effect? I mean, you say that you can prove angular rotation with ring laser gyroscopes and other little toys. You can measure it.
Yes.
But where you could interpret that angular rotation with what? With tangential speed. Now, if you interpret that to tangential speed on a sphere, if you threw something up in the air, it would drift away. There is no denying that.
Oh yeah.
Otherwise, there
Wait,
would have to be a container around the Earth.
did you miss the conservation of momentum?
No, that you can't apply that in the situation.
You threw that out there like a little time bomb.
Why does conservation
That
of
would-
momentum stop existing?
What do you mean stop existing?
Is that
Well-
how we don't feel the spin? Is that what we mean?
No, that's why when you throw something up, it doesn't fly away because it has that angular momentum.
Then there is no Coriolis effect.
Coriolis effect happens when you change your position. When you change your position, the angular speed of the ground changes.
Okay, so the stars stay in
Coriolis
place
is
and
Sorry,
the
not the-
Earth
perspective.
spins.
Sorry, not the angular, the linear speed of the ground changes when you change your position.
And the Coriolis is supposedly what snipers would use to shoot their bullets long range.
Well,
and
why
account
would
for the
that
spin of the
apply
earth.
to
I don't believe
anything?
it.
Why
but-
would it apply only the bullets and nothing else? Well, this just doesn't make any sense
Well,
at
they
all.
don't they
Well,
don't
wait.
apply only to bullets. They apply to
So
all
why
sorts
not
of
send a balloon up and wait for China to come to it?
because that's not Coriolis. Coriolis
Oh, it's
requires
not?
Coriolis is directly proportional to the velocity. So when you're in a hot air balloon, what's your velocity? If you're just sitting above the Earth hovering, what's your velocity? Zero
That-
in relation to the surface of the Earth.
Okay,
So
so that means the
Coriolis
Earth
then
would spin
is-
underneath it.
No,
Coriolis effect is a inertial and a
Let 'em-
non-inertial reference. frame.
Dude, we're making it too complicated. Let's keep it in little tiny components, one at a time.
Okay, fine. I'll step back because I'm not allowed to talk.
You're allowed, man.
just
You're allowed.
gonna
I'm just saying.
stay
Every
quiet
time he
like
starts
I was
explaining, you
before
throw out all the
because
other truths, and I'm like, I know
I'm
you're
not
right.
allowed
but-
to speak. I'm
No,
just,
no, you're allowed, man. You're allowed.
Fine.
I'm sorry, man. It's
I'm
all
just gonna
good.
listen. I'm just gonna
But
listen.
he's given long responses, and we can't keep our words enough to not interrupt him. It's frustrating for me. I'm sorry, man. It's tough for us to do it. We were doing it earlier today. We interrupt each other all the time. It's hard when we each have a lot of important stuff to say, right? Or we think so.
all right. So Coriolis effect is a force that's directly proportional to your velocity. If you're not moving, the Coriolis effect is zero. If you're moving slowly, the Coriolis effect is very small. So a sniper bullet moves fast, moves a long distance over a short amount of time, so it's enough.
Okay, hold
in
on.
long
Let me
distances.
ask you. Could you pull up the actual definition of Earth-based Coriolis effect and reference that for
I'm
me?
pretty sure he knows it. He just recited it to us, man.
I just explain how
Yeah,
it works.
it's a what type of reference frame?
It's a
Okay, you have a spinning reference frame and a non-spinning reference.
it's
frame.
routed in perspective, though, which means like relativity. No, it just always works
not
out.
relativity.
But it's like that. That's what I'm. We can
Yeah,
say
still
that
none
it's
of
always
this stuff
relative
has-
to me.
All right, I can show you.
Ooh.
All right.
Okay.
Here is let me get the right one so people can see at home. All right, so there's Coriolis force. You see this dashed line, it requires movement. So if you're in a hot air balloon and you're not moving in relation to the surface of the Earth, Coriolis effect is zero.
Is this separate from how hurricanes in the northern hemisphere spin differently or counterclockwise to the
it's-
southern, or is that something
It's-
different?
It's the same thing actually.
That's the reason.
Yeah,
Okay.
and you see here that the Coriolis force north and south of the equator are opposite. If that's on this right side.
So why do
here,
we have storms in either hemisphere spinning the opposite direction?
because of Coriolis. Coriolis
I mean, but
is opposite.
but not always that way. I mean, there's always exceptions. In the bottom, they'll spin left and right.
No, there are the exceptions are either. I've not actually seen any exceptions. I've heard that some people mention them, but I've never seen any references to exceptions.
Fair enough. I'll take that.
So as far as I know, could be wrong. As far as I know, there are no exceptions.
Okay.
And near
that
the
other-
equator, there are very few hurricanes because Coriolis is smallest near the equator.
Does that also explain the toilet bowl thing, or supposedly how toilet water spins one
That's-
way and so?
That's a myth. That doesn't.
Thank you,
actually-
sir. All right.
But the Simpsons episode was very good. So there is apparently there are people that fake it, like people near the equator in Africa. They'll go like a mile north of the equator and they'll show it, and then you go a mile south of the equator and they'll show it. That's just a smoke and mirrors trick.
I think that's disingenuous horse crap. So whoa.
So all right, so let's see. Does this have the?
So if
This
the Earth
doesn't give
is
the
spinning, then the tangential speed at the equator would be what?
About
1,000 miles a mile.
1,037 miles an
Yeah.
hour. So if you toss something up in the air, it would drift away at that speed.
No, because it's
You-
conservation of momentum. That ball is moving at the same rate as you. That's the same. What you've just claimed is that if you're in an airplane and you jump, you'll fly to the back. Is that the case? No.
Then that means
you-
the Earth's contained. Then the Earth
no,
is
it doesn't.
contained.
No, it has nothing to do with being contained. It has everything to do with conservation of momentum. Conservation of momentum is the first law
Okay,
of motion.
then then how does this bind in with Coriolis effect? Because you know the true definition of Coriolis effect.
You think you're giving us the wrong one on purpose?
It's on screen. here.
You see something drift away from a separate reference
when
frame.
it moves.
Yeah, so the Earth would be spinning and the stars would be still and they are moving away.
Oh my gosh.
I mean,
What are we arguing, Cracker?
Oh my gosh.
if the
Cracker.
Earth is spinning as fast as these people say that it's spinning, then what's the excuse for that? What is gravity the container?
Well, hold on. Like, are we equating Coriolis with the Earth spin? Or are we saying that the Earth doesn't
That's
spin, so
exactly
Coriolis
what
doesn't
it
work?
is. If you read the actual definition,
Yeah.
it's a non-inertial reference frame, which would be the spinning part, which would be
Right.
the spinning Earth. And then you have an inertial reference frame, which would be the sky, which is not moving.
So then
Now,
storms of
tell
the
me how you can interpret a angular velocity and not apply that to a tangential speed as something spins below something. It would either have to be contained.
or it's all. Oh, so
Or it's
you're
bullshit.
getting to the container, right? Like, so the air couldn't be moving with the Earth unless we had a container to keep the air pressure. Is that where you're going?
Well, that's part of it. Yeah.
No, okay.
You
know.
keep missing that Coriolis.
I don't think I'm missing much
requires-
of anything. I
requires a
actually
I'm missing
stated
something
the
for sure.
definition of the Coriolis effect.
I'm
the
missing. I want to hear it,
Earth-based
dude.
Coriolis effect.
It requires a velocity in relation to the surface of the Earth. So here's the formula. Here's the complex one here, right? You see that capital V there?
Sigma, and then what's that?
Capital V. That's the velocity moving on the surface of the Earth.
Yeah.
So if
I
you
mean-
throw a ball up,
I mean,
and it's
assumed velocity of the assumed spherical Earth.
yes,
The
we're
begging the
testing
question
the
fallacy
hypothesis.
spherical
No, we're
Earth.
testing the hypothesis.
Dude, we can't disprove the method in trigonometry. This is, solid. It doesn't apply to anything that we don't apply it to, but that is legitimately accurate.
Cracker, you brought up the
I mean,
model.
this is nice.
You brought
that
up
this
the
is in a
model.
book.
No, I get it, dude. I mean, to him, this is a proof that Coriolis is real, and this is explaining
this
the
is
world
how
around
you-
him, right?
This is the force due to Coriolis. You brought up the Coriolis claim.
This is not
And so-
Earth-based Coriolis effect.
Yes, it is. This is exactly it. Well, then give the citation, not by you, but by somebody that knows Coriolis more than this particular citation or hyperphysics here on this one. That is something else. Where is it? Where's the citation? That is.
You mean
something
a
else?
spinning non-inertial reference frame?
Let's see it. Send
This circle
the
on this
citation.
paper operates exactly as this described. That circle is what we're describing, not the Earth cracker. Maybe we should approach it that way. Modular proofs, right? Like that. What we're looking at, that's how that circle would spin, assuming that it's 1,000 miles at the equator. Yada yada yada. That's accurate.
Yeah, assuming. See, everybody's assuming things.
We're in the land of
There's
assumption,
still
bud.
no-
That's how you do science, Cracker. Clearly,
Well,
you've
No,
never done
science
science.
is done by actual
You've
experimentation.
never done science.
Abstract equations.
Listen, I know the fucking definition of science,
Right.
and
He
it's
does.
and that definition of science is something. Listen,
hypothesize,
an
prove, repeat.
experiment
Right?
proves things, something that can be repeated over and over and over again, considering all the conditions and
Right.
factors in it.
So
And you can
He-
see that in a repeated manner. That is
Yes,
science.
and you can
that actually
test
proves things.
Coriolis by
But
looking at
no-
hurricanes over and
No.
over and
No,
over again.
that is not
and
a
they
proof
always
of Coriolis
and they
effect.
rotate. They rotate.
That is not a proof of
There
As
are exceptions to
predicted.
that, but I'm not going to pick this argument, man. I was
There
curious.
are
to see what
outliers and
Coriolis
imperfections
had
in
to say.
everything, of course.
Right.
Yes.
You
But
can
this is
give
how it
this
would
a
work.
shot
If the
because-
Earth was spinning and it was a globe, and then this would be the way we would describe the Coriolis.
So now,
effect.
Cracker,
Right.
here's to you now. Explain why hurricanes almost always rotate one way north and south of the equator.
Air pressure and
Air pressure
What
isn't
do we
a
call it?
rotation, but this is to
but
Cracker.
we have the
This is to
Sorry.
Cracker. I want his proof, his non-faith based proof.
no we're
Come on, Cracker.
Non-fake-based.
proof
I'm
of
I
waiting,
want to see
Cracker.
the proof that all
Come on,
hurricanes
Cracker.
actually do
You can
this.
do it. Changing the burden of proof isn't going to do it, Cracker.
No.
What causes
Reversing the burden of
hurricanes?
proof is exactly what you're doing
What
because I'm
causes-
asking
Low
you
air
to
pressure
prove
and
that
high
something
pressure, bud.
actually drifts away when you throw it up in the air as something
the
turns
jet
into-
stream and the other one, right? The high
So
pressure,
either
but low
something
pressure.
is attaching this and
I'm
like you said,
just waiting.
conserving the
I'm
momentum.
waiting for your proof.
Well, how is that not
That's your
a first?
proof. Your non-faith-based proof.
We're in the land of
the
assumptions and
cause.
abstractions, man.
No,
I'm
no,
not
no.
saying
You have no abstractions and no
Okay, what
no
is
assumptions.
conserving? What
for-
is conserving
for
this
the-
momentum? Explain what is
I don't know.
conserving.
This
Is it
your-
gravity
this is
that's
your,
conserving
your
this momentum?
chance.
Well, you just said you don't know what's conserving
is-
this momentum.
This is your chance,
What-
Cracker, to
No,
your
I'm asking a question.
non-faith-based proof.
well, hold
What-
on. If
of
a
what is
hurricane
function or
in the
the
northern
cause
hemisphere
that
is
is
spun differently,
conserving the
would that
momentum?
prove it?
Shane, let him
My
mess
bad,
around.
dude. Go for it, man.
Come on, Cracker.
But don't attack
No, I
him.
want to hear what's conserving the momentum. Like, how is this being contained, dragged along with the Earth, and you don't have any real explanation of that?
I gave it to you, but I'm asking for your explanation for flat Earth. So go ahead.
Well, for the
You can share your
Coriolis non
screen.
effect
You
on
can
flat
share your
Earth.
screen.
The Coriolis is not the Earth turning; it's the stars. It's pretty simple.
Well, to us,
Whatever. All right,
Coriolis-
so what causes hurricanes to spin one direction north of the equator and a different south of the equator?
That's
Low pressure,
irrelevant.
high pressure.
To crack.
That's actually irrelevant on that model. It's
They would
actually
pretend and answer
irrelevant.
You got nothing.
No,
I'm so disappointed, Cracker. I thought you were gonna have
I'm
something.
so disappointed.
Come on,
you
man.
either
Let's
need
not
to
get
throw
angry.
something up in the air and show that it drifts away
Shane,
at 15
you
degrees.
get my sense of humor at least. I appreciate that. Cracker.
Well, he also
Cracker
given to us
can't.
a little bit, and Cracker's a little prickly. So I mean, I get it, but you know,
He's-
calm down, man. It's all we're having a friendly debate. There's
and
no
then
winners.
you have yet
Who-
to show me
I
proof
do
of gravity.
not-
Could you
I
possibly
do
show
not
His
me?
want
whole
to
premise is
Cracker.
that he doesn't prove anything. We're on here to prove our shit. That's what he does. No, right? We can't ask him to prove stuff halfway through. His whole premise is you guys prove it. I'm gonna sit back and do nothing and refute all your arguments. Say whatever you want.
That-
No?
I mean,
There's no-
I've shown you a whole lot of stuff.
Right. But I mean, your general approach is my show. You come on, you know, you prove flat Earth to me, right? Isn't that your stance essentially?
Almost every week I wind up just teaching a science class on earth
Right,
science
right.
to the
See,
to the
if
guest.
you, I'm
Almost
not trying
every
to
week,
prove
that's what I
flat
do.
Earth.
Well, I mean, we do observations and repeatable measurements, and then we have science and mathematics, and let's see, the triangle on a curve that is
Yeah.
supposedly where we live, and all
And
that
That's
math
supposed
works
to
by
be a
itself.
geometric definition of a triangle with curved edges. Give me a fucking break.
Dude, hey,
Really.
centuries
This
of
is
math,
ridiculous.
and you come along.
That's a
Triangle,
hill to
triangle,
authority fallacy. I don't see any real proof of
I mean, I
this
showed you
centuries of math.
the actual
Well,
exercise
that's nice
ball
magic.
with
but
real
No,
line.
the,
It's not
the
magic, it's
textbooks
a
that we got
physical
fooled
ball.
with, he referenced, dude. He's right.
You showed me cartoons and math, but you haven't
True.
shown me any real proof of this.
We're not.
All
You
right.
haven't shown me anything that complies with
All
your
right.
15
Well, let me
degrees.
get to some.
Okay,
some,
15 degrees per hour is 15 degrees per
yeah.
hour.
All right. Three Ron. Three Ron is-
Translated
it-
to
yeah.
the spin of the Earth, if you put it at a certain position on the Earth, it would spin at what? A tangential speed of
Yeah, the latitude
that.
times, or sorry, the cosine of
angular
the latitude
velocity.
times
Exactly.
the equatorial velocity.
It ends up being what if 1,000 at the equator, then at 10 degrees, what at 16 kilometers,
So-
20 degrees, 1,500 kilometers, all the way down to 289.
Well,
that
80
maxes
degrees.
out.
It's
or it-
non-linear. It's a sine cosine relationship.
Yeah, it's about 600 at 60 degrees, right?
I don't know.
So why don't things fly away at 600 miles an hour as
Conservation
the
of
Earth
momentum.
turns believe it?
Dude,
Gravity,
we-
buddy.
Yeah, gravity. Okay,
Cracker.
so show me
All
the
right,
experiment that
listen.
proves gravity with the independent variable as the cause that
I don't want to
All
mess
right.
with gravity.
observed
All right,
in nature.
Cracker.
Show me the experiment. No,
Hold
no,
on,
no.
Cracker.
Show
Let me
the
explain
experiment.
this.
And don't say Cavendish.
We homeschool our kids. I
Smart.
teach science
I
to
don't
my
care
kids.
what you do. This is irrelevant to
I
whether
know
this is
when
globe, hush.
conservation of momentum is taught in elementary school. It's about 4th grade.
That's the same to explain
And that
the
means
when you
what?
spend-
That means that you must have missed 4th grade.
we're not refuting the concept, just the application of the concept.
See, this is ad hom bullshit. You have no
His
explanation.
technical basis is what he does, man. We knew that. I don't know why you're surprised and angry right now. Like,
Come on, Cracker.
mean-
less
the-
prickly. Let's get a soggy Cracker.
Cracker,
That's-
honestly, dude, if you don't know him, is one of the smartest people I've ever met. He's a little bit upset and emotional now, but he's
No,
he's knowledgeable
You
on
guys
damn
getting
near
that I'm
everything.
emotional? What? Because
well,
I'm
just no, because you're angry
You're
at
my
him
normal-
for some
I'm not-
reason.
I'm not angry.
I counted a couple
can-
F bombs and
just-
I can feel.
not
I can feel
getting-
the anger.
Oh my!
do you got
You can feel the frustration. There's a difference.
maybe a little bit
All
anger
right,
too.
all right. 3Ron has something to say. I think to you, Cracker. He says, "Typical flirfs have nothing and are a joke."
I don't want to hear ad hominem attack.
Oh, you got me. Oh, my emotions that got me hurt.
Oh,
To be
that
to
hurts
be
so much.
to be
This doesn't prove
specific.
shit. I want to see.
Oh, man.
To be
I want to see
specific,
some
that wasn't
evidence.
an ad hom.
Okay, listen.
That was an
I
insult.
get
They're
one
different.
question.
we got that, buddy.
I
Thank you.
want to see
Clearing that up.
an experiment that proves your version of gravity, and I want you to specify whether that
I
is
don't know.
Newtonian.
You don't want. I don't want to go into
math.
gravity. You want to go into
I want-
gravity?
Yes, I do.
Okay.
All right. Well,
Because this is the glue that holds their piece
all
of
right. Well,
shit
well.
together.
I'll start with this. I don't do pseudoscience. Demanding
Mhm.
proof.
Okay, then
is-
show the experiment
Yeah, proof is
and show the cause,
pseudoscience.
which is the independent variable.
What?
Now, and
What's the
so
independent variable of gravity?
now I will
Of the
not.
experiment that proves
Let him
gravity.
talk. Calm down, man.
All right. You don't know what science is. You're not a scientist. You don't.
Yeah, right.
I'm
Ad
not.
hom again.
I'm not.
I want
that's-
to see the experimental proof
I-
of gravity,
I-
not
I
ad hominem
wasn't done
attacks. Okay,
explaining.
I'm gonna go get a
So-
drink.
I will not be using your version of science. I will be using science as scientists do it, and the same science that developed computers that we're using right now to communicate
No
with each
way.
other. So the demanding very specific things is not how science is done. That's a form of science denialism.
It's an
So, now
emotional
he
argument.
said he's going to walk away. He wants me. He demands that I tell him something, and then he walks away. So
He's just frustrated. Let's give him a minute. I think
I get it.
Okay, no, I went to get a drink. Seriously,
that was
but
quick, dude.
All
I
right.
still haven't heard any experimental proof of gravity.
I want to let's
I'm
go.
sorry.
I
grab
believe
throw-
the
throw it to
equation F
McToon.
I'm
equals
not
G
doing-
times
I'm
M1
not-
M2 over R squared, right? Do
I'm
you
not
agree
doing
with that?
pseu-
Do you
I'm not
agree
doing
with the
Stop, stop.
equation?
Cracker. This ain't going nowhere,
Agree with
bud.
the simplified gravitational equation.
Cracker.
Even
I'm
if you're
not-
right.
I'm not
No,
doing
I'm
not.
pseudoscience. So if you
M2
demand proof, I'm going to just
over R
say
squared.
you're the pseudoscientist. I don't do that.
This is part of your model.
Well, hold on. How would you? Do you not prove? Do you not go into gravity, or you just?
I'm
how do we
happy to
do-
talk about gravity, but if
Okay.
he's expecting, if he's
Okay,
going to
I
be
want to see
talking about
experimental
proof, if he's talking about proof, then I'll just say you're the
Then-
pseudoscientist. I'm not interested
I'm
in
not the
pseudoscience.
I want to see what he
I'm
has
the
to
one
say, man.
asking
Give him
the
a chance,
question.
right? But
I'm asking you a question.
Yes,
Can
you
you
are
provide
you're-
experimental proof of your
Yes, you are asking for
gravity?
pseudoscience. I don't do
I'm-
that. I'm sorry.
Okay,
I
let's see
don't
what
do
he does do.
pseudoscience.
then you're
That's
saying
your
that you
thing.
have no proof of gravity. then,
I'm
right?
saying that proof.
Then you're saying you have no proof of gravity.
I'm saying that proof.
You're saying that you
Oh,
have no
all right.
proof of gravity.
All right. Let's see here.
Correct?
How
Okay,
would-
so now
let's
he's
just
going to run.
toss it to McToon, and we'll give him gravity. Go, silent or not part.
All right. I am done with Cracker. All right.
Fair enough.
So he
How long do we go here?
He's incredibly rude and will not let me finish a sentence. All right. So if he's
Understood.
going to be like that,
That's your
he's-
show, man. You're the
then
boss.
he won't be here. All right. I'm happy to talk to you because you can have a conversation.
Sure.
So let me fix the
How long
presentation.
did we plan on going? Was it 2 hours, an hour?
I'm good. I don't have anything else going.
Sweet. All right.
All right, let me. I have this from last week. All right, let me get this out of here.
Cracker getting insulted by comments. Really? We've never had bad comments? We live
All
in
right.
bad comments. Relax.
All right, so he kept demanding proof. We covered it earlier. As soon as you say something's been proven, it is no longer part of science. Every single thing in science is eligible to be questioned, right?
And you must be willing to change your perspective when given new information.
Absolutely. So once you've achieved proof, it's no longer to be questioned.
Which
So
is not science.
science does not prove. It can't, because then it's not questionable. Right?
I mean, I know where he was going with it, but
So
is a little
he
bit
wants
emotional.
evidence or confirmation, right? But then what he did is he went into telling me how I had to do science. He
Understood.
not being the, I mean, he's not a world-renowned educator on how to do science. He wasn't citing any particular third party, since he's not the expert, right? I don't think he's going to claim to be the expert in science. He wasn't citing anybody. So I like to look at how the University of Berkeley talks about science. They have a website, Understanding Science. It doesn't say you must have an independent variable and all that kind of stuff. It generally says that is, you have a hypothesis, you test a hypothesis. That's how you do science.
With no control group?
And that the very specific rigid rules of what people get when they're in middle school is too rigid, too strict. It's not flexible enough. So if but you absolutely do want to control for confounding variables, without a doubt. So that's where you want to include refraction analysis. So for gravity, and he said he didn't want to hear about Cavendish. I don't care. Cavendish, his particular experiment, I don't usually cite because it's been done more recently in more interesting ways, including by somebody in his own apartment in Korea when he was stationed there for a while. He was serving in the military there. All right, let me get.
Is this the
You see that?
mass one?
So this is
yes.
So this is, you can see this is a bar. This is a view from the top, and you can see a bar. There's two lead balls on either end of the bar, and at the bottom you see this. You see a light. So there's a mirror. The mirror is on the torsion wire, and then there's a laser, and you see that black bar there.
Oh yeah.
And that laser is so the left side of that laser is right where that black bar is. Right? And so this is BM Furball in his apartment and you can see him talking in the corner. I'm covered up. I'm covering him up like right here on the edge. People at home. This is where BM Furball is talking. I can maybe fix that a little bit. But he has, from the other room, he's able to rotate into place the masses. There they are. You see those 40-pound weights? They're just, he took some dumbbells, he cut them off, and he moved them into place with a Raspberry Pi controlling a motor. And he got them closer there to the balls on the torsion wire. And now I'll forward it. It takes forever, so I'll forward it. You see how that light is moving?
So this is a mass attracting mass experiment at its core, right?
Yeah. So it caused a twist in the wire, and then it has an actual it oscillates back and forth, and then over time it settles. And it settles to the left of that black bar there when it's done moving around. So on his own, a guy with a small budget was able to put together his own test to see if mass attracts mass.
And the science community repeated this experiment, or?
So the scientific community has repeated this in much greater detail than he has.
Okay. And the force he calculated was
he did not have a tight enough controls on the torsion wire to calculate the actual force.
Just that there was a force. I guess.
This is just true false. Does mass attract mass? If it does, and here's the hypothesis: if mass does attract mass, then when the oscillation stops, then they will be closer to each other. And if mass does not attract mass, then when the oscillation stops, they will be in the same places they were to begin with. They were closer.
6.667 times 10 to the negative 11. That's a measurable force. That could have been an air torque.
That was
that later? They found out the actual force, or
Oh,
is this wrong?
the gravitational constant is not a force; it is a constant.
Well, the mass attracting mass, wouldn't it be the force he measured wasn't the gravitational constant? Wouldn't that be different? Like the way a massive planet attracts a smaller moon?
Yes. Yeah. You can. What about it? You just quote. I mean, you quote. It sounded like you just quoted the magnitude of the gravitational constant.
If someone measured the force in this experiment as 6.67 times 10 to the negative 11, that's not the gravitational constant. Isn't that the 9.8 meters per second?
9.8 meters per second squared is the gravitational acceleration, approximately all over the Earth. It does vary.
Oh, enough.
The gravitational constant, capital G, is what you were talking about. And of course, there's units on that as well that you didn't quote.
The Polaris Society says that we're a disk accelerating upward at 9.8 meters a second. No one believes that. Just throwing that out there. That's nonsense.
Well, Tom Bishop and Pete Savary are doing.
Who are they?
They're two of the people on the Flat Earth Society forums.
Oh, yeah, no, I've never been there. Everything they say is nonsense to me.
They are the two main editors of the wiki page on tfes.org. They had a falling out with the people on theflatearthsociety.org quite a few years ago and broke off and formed their own. They're like, I'm going to take my toys and go play somewhere else.
Right. Well, by the time I was looking into it, everything I found there was, to me, stupid and nonsense. It made me go right back to the globe. The Flat Earth Society is not what I would use as a source. And it's kind of disingenuous to use that as Flat Earth perspective.
I don't. Did I?
No. I'm just throwing it out there from the disc thing, right?
I do have to say, they are very serious, and there are flat earthers that have that position. So I hear a lot of flat earthers say that nobody believes it. That's wrong. Some do. They're all just as silly as the rest of y'all, but right?
for sure, I get you. I mean, but for them, they mix science and pseudoscience and nonsense, and it's purposely misinformation.
That's exactly what. I never mind. All right. So this is one. Now this is just to show that when you introduce that mass, they do wind up next to each other. Now this was encased inside of a Lexan box in a room separated from the rest of his apartment. He had a 2-bedroom apartment. He covered up the vents in that room. He taped the door shut in that room, and he did not enter the room. So when he introduced those particular masses, he did it remotely by having them move using a Raspberry Pi. And then when he was done, and the oscillation was done, you can see here, I don't know if this part of it is where it's oscillating is done, but you can see where that is to the left of that black bar that he drew on there. And later, here, he takes them, I think he takes them out here in just a second.
Should there be a control for this experiment to see if the two would also not move at all? Right? No.
The control is when there is no mass present. Yeah. So the base position here. Here's at the beginning. There's the control. The test masses have not been introduced, and then he introduces the test masses. Let's find it there. There you can see the test masses are there. So there's your test. You got your test and your control. You can see the Lexan box that it's in. He graphed all these things out. Then, let's see, I think he moves them. That's not it. So he also did, this is pretty fun, he used, instead of weights, he used magnets on both sides. He got some big, strong, I think, neodymium magnets. And when he introduced the magnets, what do we know about lead and magnetism?
magnetic.
What is lead in relation to magnetism?
You mean polarity wise or attraction wise?
Attraction.
Magnetic, super dense, very magnetic.
Diamagnetic.
That's the word. Which
it is repelled by a magnetic force.
But it still undergoes electromagnetic force, right?
I didn't say electromagnetic. I said magnetic. So when he introduced the the magnets and then let the oscillation stop, it actually repelled them. So that could be, if you wanted, it can be another control, because
is that how we're going to say that the movement wasn't the magnetism force, that it was in fact gravity? Is that what that part was for?
Because the magnetism repelled it.
Right.
Yeah.
So you're saying that the attraction that they move closer together is therefore the proof of gravity in this experiment. That was the conclusion.
It's the confirmation of the hypothesis. So let's see. Yeah, here's a 10-hour video. So he live streamed the whole thing. So the oscillations were very slow. You can see here there's no masses. This is early on. He doesn't have the
what about like friction and air resistance and all the other stray forces in the room there? That seemed a little bit.
Friction actually will cause it to stop oscillating over time.
Right.
If there was no friction, then it would oscillate indefinitely.
Perpetuity, right?
Air resistance he controlled by having it in a room with no vent, taping the door shut, and having it inside of a box inside of that room to prevent extraneous airflow. But he couldn't do a vacuum chamber like would be some people do. All right, so if I scrub across here, you can see that it's moving around. You see that?
So why isn't the force constant as it should be?
The force is constant, but conservation of momentum causes the oscillation.
So it's such a small force, the constant over time ends up in this small deviation. That's what we're...
Well, over time, the friction causes the oscillation to stop. Right?
Right. Did he measure it when it was stopped, when it was still in oscillation?
Yes, he measured it when it stopped oscillating. So people have done much better and more precise measurements than he has in that one here. So this is
shouldn't there be like a mountain attracting something smaller to it next to it? Shouldn't a mountain pull all the things to it then, if this is...
Funny you should say that. This is on mctune.net/G. And it's on this list. They did it at, there it is, 1775, an account of the observations made on Mount Schehallien for finding its attraction. So they actually used a pendulum at the mountain, and at different points in the mountain they determined the deflection of the pendulum was more or less. The mountain actually was attracting it.
This is different than the, what was it called, the pendulum experiment. Hold on. Good. Yeah, so not Foucault's pendulum, that's a different experiment.
Foucault's pendulum is measurement of the rotation of the Earth.
Right, my bad. Continue.
All right, but this one here in particular is nice because they do a lot of things in it to control for confounding variables. So one thing that BM Furball did do was he grounded the things so that they'd be at the same electrical potential. But that's a potential source of error, that there would be a static force between them. If there was a static force, if their charges were the same, they would repel, and if they were opposite, they would attract. But if you have everything made out of a stainless steel material like this one, and it's all connected to each other. Let me see if I can find a good picture. Then they're all going to be at the same electrical potential. There we go.
So we're negating the effect of the
Yeah. So static electricity or anything like that would be negated. You also have they used materials that are very slightly magnetic instead of strongly magnetic. So and then they demagnetized them, and they measured the magnetism in them. Very, very small. So they did things to control for that. They had them machined to a very small size, deviation in size, so that they're the same size and mass. And so this particular one outputs the gravitational constant using two different methods. But the important part is whether or not, the question is, does gravity exist? Does mass attract mass? And when they put these in there, so I'll get back to the picture of the, so that they use this for a torsion.
I mean, if we weren't looking for gravity, they could just do the same experiment and say there was an apparent shift in these two objects. So they would just say, oh, something else, right?
Well, this is science. You have a hypothesis. If mass attracts mass, then when we introduce a mass, there will be an attraction between them.
And we'd have to eliminate all the factors, right, to make sure what was left is in fact the force of gravity.
Exactly. So you want to control all of your confounding variables. And so this was done, and you can see the dashed lines around there. This was actually done inside a vacuum chamber. So they evacuated the air in it so that the wind currents weren't a factor.
And how do they measure the distance? Is there a string or
there's a torsion wire?
Okay.
It's not a wire. I'll show you the picture again.
Gotcha.
This right here. This little flat piece of metal that they used so that they could get the torsion strip and its mounting. So a sheet of 30 micrometer thick copper beryllium is what it is, which is a very non-magnetic metal. It's specifically chosen because it's not very magnetic. So when the masses were introduced, it caused a force, a measurable force on the torsion wire there.
How do they cancel out inertia when it was put in motion from the first law of?
So, well, it started at rest,
Right.
but even if it didn't start at rest, you can use the maximum and minimum of the oscillations, and so you could have them oscillating, and then you could measure the two extremes of that particular oscillation. And then you introduce your mass, and then if the oscillations shift to a different position, then your average of those two positions is the center of it. So they actually use two different methods. The time of oscillation changes it, and I think the center of oscillation, because like I said, there was two different measurements that they came up with at the end. Two different values for the gravitational constant. And here it is. 6.67515, and then 41
ppm.
is the
Oh,
that's their margin of error that they're talking there, and then 6.7.
what units is that? Oh,
meters cubed over kilograms seconds squared.
interesting. That's definitely in depth. I mean, to me, not to backtrack, but yeah, if you can explain how things work around you without force of gravity, then this seems like a lot of extra work for nothing, right?
Well, they were measuring the gravitational constant. They weren't testing whether or not gravity exists.
I thought it was mass attracting mass.
What's that?
Aren't they testing directly mass attracting mass?
This is a measurement of the gravitational constant. That's what the purpose is of this particular measurement.
That all mass exerts on all other mass, correct?
The law of universal gravitation is a law. They weren't testing that, but But we can look at this and we can look to see that they did in fact confirm that it does exist, because when they introduced a mass, it caused a deflection in the torsion wire, just like the one that BM Furball did in his apartment. This one did. So I'm showing you the two extremes, right? You can do it in an apartment, and you can do it in a vacuum, in a chamber that's been evacuated of as much air as possible, and you can get extremely fine precision measurements, right? 1, 2,
So is that
3,
force only from that
6.
weight to the other weight, or from all mass to other mass?
All masses attract each other
By that amount, by that factor. Gotcha.
That's the law of gravitational attraction. And in the law is a variable, G. This is the value of G.
But it is a constant, right? Yep. So yeah, I got you.
All right, I have Kitsumi Convalier sent the one where BM Furball did the magnets. I loved when he did this. This was a surprise. I think I was watching this live when he did it.
Were you? Oh, this wasn't that long ago. Yeah, you probably.
And there you can see that it moving in. You see the thing on the bottom twisting.
What's with the glow on the bow? Is it the background?
Yeah. And so that's a neodymium magnet coming close to the lead ball. And you can see the lead ball actually moving away. Very slowly, but it's moving away.
From the magnetic propulsion, no?
Yeah, because lead is diamagnetic. It's repelled by a magnetic field. And so we brought in a strong magnetic field, and it caused a deflection, the opposite of what he's had when he introduced a mass that was not magnetic. So I have a flat earther who's a moderator, and
that's fair.
And people are like, "Why do you have a moderator that's a flat earther?"
To be
like,
fair and impartial.
I don't want him to moderate for the most part, because, but I want to show that I'm not going to just be
predetermined,
one-sided.
jaded. Right.
So,
although I didn't see any interaction from the moderators, right?
And he lives near me, so I keep hoping to meet him in person.
Really?
Yeah.
You want to meet a flat earthers?
Well, I've met a few. I went to the Flat Earth Convention in Dallas
in
2019.
How was that?
It was weird. We got kicked out of the lobby.
Did you just go around showing everyone the globe or what?
No, we were actually just walking around looking at the displays.
How'd they peg you?
And Robbie Davidson shows up with his the rent-a-cop guy, and he's like, "You gotta leave." Like,
you must have been recognized, right? They were like, "Get him out of here."
Yeah, he knew where. Well, I was with Team Skeptic, and Team Skeptic had introduced himself to Robbie Davidson.
Gotcha.
So a couple minutes later, here he comes with the rent-a-cop guy, and we're walking away with the rent-a-cop, and we're like, he's like, "Sorry, man.
Why wouldn't they want you there? The whole method of it is to invite people to show people like you what we think, not to kick you out and oscillate you. That's silly.
I can see a few reasons. To be fair, the year prior was when what's his name, that pretended to be a flat earther, the big YouTuber,
Sergeant.
No. Can't remember that he's not a flat earther. Darn it. People in the chat help me out.
Right. Come on, guys.
Logan Paul, there it is. Logan Paul went and totally trolled. He trolled the whole
when they
thing.
made that fake thing, I remember that.
Yeah,
That's
and so this was a
fake.
year later. So Robbie
Gotcha.
was, kind of.
But you didn't make it, right? You weren't involved in that.
Yeah, but to be fair, Robbie Davidson didn't know what our intentions were, and so I can somewhat understand.
I mean, it's supposed to be a warm, welcoming atmosphere of everyone getting along instead of kicking out people who don't agree. That's right back where we started, guys.
You'd think. All right, I've got a bunch of questions, and we're over 2 hours. If you don't mind going through a few more of these.
I'm with you, man.
Many Karen says, truthers, We know everything about the globe and heliocentric model. Also, truthers, I've never heard Polaris moves.
It doesn't move though. That's not proven. We just recited that.
mctoon.net/Polaris.
No one here can verify that in their lifetime, so I'm gonna put that as a neutral. But I appreciate it.
Rags says he's not a fan. He says it's like they're having a stupid contest. Then,
ouch, man, my feelings.
Lael, well, I mean, you got to have kind of thick skin, don't you?
I gotcha.
Lael says his argument is flawed. I've never physically been to China. However, I do not ever need to go to China to know that China exists.
Okay.
Right?
Pass. Did I miss how did we argue that, or was that a cracker thing?
I've got a globe Earth detractor in the comments here. It says Matthew Heinlein says, Toon, G isn't a variable. Why are you always wrong?
Read that one out too. I appreciate it.
I'm sorry that I wasn't as pedantic as you. Enjoy. I'm sure your pedanticness keeps you warm at night when you're all alone in your bed with nobody to love you because you're so pedantic. I'm kidding. I don't. He's a pretty bright guy, and he keeps me on my toes, and I do appreciate that. Eddie Reese, how many photography classes has Cracker taken? And what type of camera does he prefer to use when confirming clouds are behind the sun?
No, that was me. So I'll save Cracker from that one. That was my example of my, my right.
I mean, I recognize those were not yours. They're somebody else's. Have you taken any photography classes?
No. Why do you need a class to operate a camera? Did you take a class to work your computer?
Well, it would definitely be good. I chose to, instead of taking a class, I read several books and participated in some online forums. There's a book called Understanding Exposure by Brian Peterson, an absolutely fantastic book that anybody who understands enough about photography would look at the sun and the clouds stuff and say, oh, I understand exactly what's happening. So that's why you'd want to get an education on it to understand from people that are professionals or experts in that particular topic.
Right, but that doesn't explain what we're seeing here. You can't explain away
it
before and after.
Explains it, yeah.
Fair enough. That's not an argument I can win on a technical basis with you.
I mean, you got to understand, and you're right. You not having had that education can't say whether or not somebody with that education could see
correct.
That, so.
I was hypothetically emotionally commenting.
Yeah. So all right, we've got Cretan Bull says 2 guys offended by the suggestion that they can't do math, don't know what a planar triangle is.
That was a good one. I'll take that one.
These are the guys who are going to debunk Einstein. So, Connell Silverfur. I think this might be, who is the lady that was in here? What's her name?
Bella. I didn't expect that.
Well,
we have a group chat all the time.
This might be for Bella. It says, if your guest would like to argue the Bible, I'm more than willing to hop on and discuss what the Bible teaches with her regarding the earth.
But hold on. What does the Bible teach, does she think?
Connell Silverfur is a Christian, so is familiar.
His 660 Bible verses that speak of a flat earth. I mean,
I've read all 200 that are claimed to suggest that, and not a single one says that the earth is flat.
They call it a circle, right? And then around the corners, and it gives it foundations and a couple other things.
Exactly. So. And none of them say the earth is flat. So Inquisitor Rurik says 2009 is calling. They want their flat earth arguments back. I
wasn't around then, so it doesn't hit me hard. I'm sure you can do better.
I gotta say, you're kind of recycling kind of older ones. Tommy Grunwald says, strawmanning what? Please be specific. I think he was talking about how you said at the beginning that globe earthers often strawman the flat earth model, flat earth in general.
With those specific examples, I don't want to take all the arguments off the table, but the flat rotating disc accelerating upward, nonsense. Let's just call it that.
I agree. It's one of I've identified 6 explanations for gravity by flat earthers. 6.
That is buoyancy, density, viscosity, and electric charge of the earth is a pretty good one. That's the basic observation that we see.
Buoyancy and density I put at number 4. In number 6 is the most ridiculous. Number 1 is the least ridiculous.
Let me hear
him. Number 6 is actually just if anybody's on Quora, I just posted it on Quora. I'll just pull it up. So incoherent dielectric acceleration is the most ridiculous one.
That's nonsense. That's cool.
Because it's just 3 words. Nobody actually does anything other than say those 3 words.
What
That's
else?
it.
What was the?
I've never heard any flat earther say anything other than those 3 words. And that's it. I'm looking for my...
What was the most ridiculous or the least ridiculous?
That was the most ridiculous. The least ridiculous. I mean, it's still ridiculous. The least ridiculous is centrifugal acceleration, that the Earth is on a platter of some sort, and that either it's suspended by cables or something, or it's on a train track type thing, and it's actually rotating in circles, and it's centrifugal force that is the cause of it.
I'd rather go with Stephen King's turtles all the way down explanation than that one.
Well, turtles don't explain it, but that's the one. That's the one that is the one that actually does in my opinion, the best job of trying.
So when we observe what we see around us, we try to explain why it's doing what it's doing, right? So, I mean, if we observe a ball falling, we go buoyancy density. We don't have to, gravity isn't necessary for anything that we see, witness around us, except for the heliocentric model and the moon and the gravity and planets.
Absolutely is, because there's a specific magnitude to the downward acceleration. 9.8 meters per second squared, about. It varies.
Based on the latitude or?
Latitude and elevation, as well as other less prominent factors.
Which
and it's
force
predicted to better than 0.1% using just elevation and lateral velocity.
But what is that describing? What object or motion or interaction is described by that gravity force and by no other force in this Earth?
Well, like, gravity and centrifugal force together. But it's a very particular downward acceleration. Buoyancy and density doesn't actually answer that particular question.
It doesn't determine
what is
down.
the magnitude? It doesn't even give us. It doesn't even give us the direction of down. That's why it's not a very good explanation.
How does it not? The Earth is a charge, electromagnetically charged, and as you go up, it gets higher and more.
So when you equalize the electrical potential, then there is no more charge. So if you're touching a wire that's touching the ground, you're at the same electrical potential as the ground, then you would just float.
If you added a charge to that, then you'd float, right? If you took away the charge.
If you equalize the charge. So if it's electrical charge, then if you have a wire going to the ground, then you're at the same electrical potential as the ground, and you would float. It would be really easy to get something to the top of a tall building. You just have a wire that's long enough. You'd poke it into the ground, and you'd attach it to the thing that you wanted to bring to the top of the building.
You can
and
ground
you just
yourself,
give it
but not ground.
yeah, you just give it a slight push, and it would just float the way up. That doesn't happen. If it's electromagnetism, then in the inside of a Faraday cage you'd float. If it was magnetism, then lead would float, as we talked about earlier, because lead is diamagnetic.
The electromagnetic portion only describes which direction is down. Buoyancy, density, and viscosity are responsible for all the rest. The only thing the electron portion does is point you downward.
No, but it's not downward. It's downward with a particular magnitude, right? It's a vector. Vectors have
a very weak force, isn't it?
Vectors have both direction and magnitude. So, and the downward acceleration is a direction with a specific magnitude of 9.8 meters per second squared, about.
So why wouldn't we just say that's the electromagnetic charge pulling you down?
Because, like I said, if you were grounded, if you had the same electrical potential, there'd be nothing. That force would be zero. You'd have no charge, no direction.
What if when they do that electromagnetic levitation thing where they give it a charge and they send it around the bowl, you know what I mean? That little disc that goes around the outside of the bowl. It's not defying gravity, right?
It is not defying gravity. It is still being pulled down, but there multiple forces can act on an object at the same time. You know that, right? You could blow on something while it's Two people could blow on the same thing at the same time
Right.
and get pushed at the right. So gravity pulls it down, and that magnetic locking holds it up at the same time. Just that the magnetic locking is stronger than gravity.
Well, in our world, the gravity is a weak force, right? In the globe model, it's a very weak force, and so is the downward force that we ascribe to electromagnetism of the Earth. So I mean, that's how it works for
But
me.
it has a specific magnitude, 9.8 meters per second squared. What is the cause of that? Where do you have the magnitude of that acceleration?
I couldn't tell you. I don't know that one. But
$10,000 could be yours if you could do it. I have a $10,000 challenge.
I mean, you know, when you ever see the Truman Show?
Has nothing to do with
No, just an aside.
thing. Yeah.
When he says, you know, I want to be an explorer, and they go, oh, you're too late. Everything's all explored already. Would you rather live in a world where everything has an answer, or where there's lots to explore and things to experiment?
We don't have an answer for everything.
The globe model certainly does, actually.
No, it doesn't. There's lots of
what can't you explain?
There's lots of unanswered things. We don't know whether or not quarks are composed of other particles or not. We don't know that. We don't know all the details about neutrinos. If you want, you can go participate in some of the neutrino experiments. There's one at Fermilab that's sending some neutrinos down to a mine in South Dakota. Right? We don't know the specific area of the Lake Titicaca. Right?
But that's not specific to the globe.
Somebody
that's
could
just shit we
go
don't
measure.
What about the heliocentric model? I don't think anything about the model they teach you has any unanswered questions. They don't like that in the textbooks. They have an answer for everything, don't they?
When it comes to because the shape of the Earth has been explored for a long time. There's not a lot of questions about it, but things like they use WGS-84 right now as the one of the major ellipsoids for the what is considered to be level. Level is an ellipsoid. And they are changing that to be based on gravity, actually. It was going to happen, I think, last year, but it got delayed because of all the upheaval.
Pandemic thing. Yeah, we'll call it the thing.
So they delayed the particular switch over to that, but that's what surveyors deal with. And I have quite a few surveyors I've been on my channel, including a guy that's a university professor who uses this book. This is, I think, the 13th edition. They use the 18th or something edition, 16th edition. I don't know, in the class. So I've read not all of it. I haven't gone through it, but the ways that they've measured the shape of the Earth is well understood, well explored.
It's certainly in a lot of textbooks. You've gone over the 16 emergency flights that prove flat Earth. I'm sure you've seen that book and someone's brought it up, I presume.
Oh, they have, but yeah, I gotta say, Flat Earth Banjo, I think, is mentally handicapped. I don't want to poke at him too much, but he takes and he maps it out on Flat Earth model, the AE map, and then he maps it out on a globe projection, typically a Mercator map. He doesn't actually map it on the globe, so it's not the actual correct.
So he's measuring the flat the square map, right?
He's not doing navigation, how navigators do navigation. He has no clue how navigators actually do navigation. And he's doing it wrong and then saying, oh, look, it doesn't match. Of course it doesn't match. You didn't do navigation how navigators do navigation.
So he's saying the globe portion of his measurement was flawed from the beginning, so therefore it's not unequal comparison.
It's not a measurement, but don't need to be too pedantic there. So
curious.
Pilo 1408 says, didn't these two claim to know the globe model?
Which part didn't I know?
Well, you didn't know that the globe says that stars move.
No, but I mean, that's what we can't
Right.
measure that, right? We can only see the
But
star,
that's
the
part
North
of the
Star as
globe
it
model,
is.
isn't it?
It is, but there's no proof of that. You can't measure 1,000 years ago.
It's
You can
not-
only look
it-
at the same book, right?
You said you know the globe model. That's part of the globe
But-
model.
It is. It
You
is.
didn't
The
know it,
North
though.
Star is part of the Nobel.
So you
I would say
didn't
that the
know
fact that it moves is debatable. Let's do that. To me,
obviously this is, we call this a debate. I mean, I'm sarcastic when I say it, but let's see here. Somebody's comment there got missing. Let's see if what he said. Tommy Pilo Kirkby. There it is. Kirkby, no message. All right, so Kirkby asked a question but had no message. Sent something. Don't know what that was. So
I'm sure it was hurtful. I'll assume it was rigid.
oh, he's nice. Mr. QTube, first name Fa, says, "What's the mathematical formula for nuh-uh?"
It's G equals V cosine 2, I think, actually.
Is that radians or degrees?
That's a good one.
Delcos says, "Wonder why gravity is used in some robots I work on." So Delcos has a
It's not.
robots.
But okay.
Isn't that a faith claim? He works on it, not you.
All right. But he doesn't use gravity the same way that engineers and architects don't account for curvature.
But they do. All right. Many Karen says, "Truther, it predicts, it doesn't prove. And that, children, is what we call science."
Truther, it predicts, it doesn't prove? I don't understand.
Science doesn't prove. Cover this.
Gotcha.
If it proves, then it's not available to be questioned.
Gotcha.
It predicts. You have a hypothesis. From that hypothesis, you predict something. And then you test that prediction. And if that prediction works out, then you've confirmed your hypothesis. So then you repeat. You do another prediction from the hypothesis. And if it works, you've confirmed the
I
hypothesis.
gotcha. I didn't hear the
again.
first word. That's why
Yeah.
it didn't make sense to me. I
After you've tested many different predictions and they've all been confirmed, that gives you some more confidence that the hypothesis is correct. If you have a bunch of tests that are wrong, when you put it together, you do your actual prediction and you find that it's wrong. Well, then that shows you that the hypothesis is probably wrong. That's science. Nowhere in there is anything proven. Is it still up to be questioned? I got an email this week out of the blue from somebody I'd never heard of. Pretty sure he's a flat earther. Said, if you can't question science, it's pseudoscience. Like,
True.
Absolutely
agree.
Absolutely. And that's why we don't say prove. Sometimes in common parlance, people throw that word around, but that's not really a specific.
I think our version, our meme is the science worshippers method is to formulate and plagiarize a hypothesis, construct a model based on preconceived ideas, find data that agrees with model, discard data that does not align, shout trust the experts. Just throwing it up there.
That's absolutely not what science is.
No, that's the science worshippers method as compared to the scientific method.
Oh, yeah. And when I've heard people say the science is settled,
Nonsense.
like
Like Fauci. Fauci says
I
that.
don't-
Come on.
I don't
I am
like
the science.
anybody that says the science is settled, right?
Yeah.
Because it goes a little bit right into the claim of proof, right? That you can't question it. So, all right, William Foley says, I now know where everyone who failed or hated math and science in junior and high school ended up.
You'd think so, man. I did lots of high level math and I always got straight A's, dude. It's not that I suddenly became stupid. It's that I applied it differently than you did.
In high school, or did you
High
go on
school,
to
college? Yes,
university?
sir.
What did you
Yes,
study
sir.
at university?
Computer science and English.
And so
So
you
JavaScripting, HTML, discrete math, upper calculus, all that good stuff.
you took calc for a computer science degree?
Discrete math is what they called it, but it was the upper level math with no numbers, essentially, not the integral calculus area under a curve stuff. The discrete math is
Okay, so not calculus. Okay.
Well, I did calculus was a prerequisite. I took all those courses just like
Okay.
everyone else.
All right.
We can regurgitate with the best of them, man.
All right. Eddie Reese says, which camera has the magical zoom? I'd buy it.
The P1000. It's a magic flat earther lens. You got to get that's why it cost $1,000. Sorry.
All right. We've got Indie Tiger's sci-fi review says, I navigated ships in the Navy. Ships on the open ocean make pre-calculated course changes to get to where they are going because the Earth is curved.
That's silly. Why do submarines on the bottom can contact each other from 1,000 miles away? Shouldn't it be below all that curvature?
How do submarines contact each other?
They're like they have separated by 1,000 miles. Submarines can contact and beam each other and transmit and tag and radar. But shouldn't that
You
radar
can't send radar through 1,000 miles of water.
right? Well, I mean, whatever
It can't
submarine.
radar doesn't go through water well.
How do submarines? Is it sonar? How do they detect
sonar? But it doesn't go 1,000 miles.
Well,
But
I don't know
sonar
that
sonar
distance.
goes in all directions. So
And it goes
it'll go
further than
around. It'll go around topography.
I see.
There's no
Withdrawn.
problem with it. Because light, if there's no refraction, reflection, gravitational masses in the way, light will go straight. So there are things that can cause it to change, but in general, light goes straight. Sound, sonar, this goes in all directions. So
but
sonar
not
is
through
just
objects, right?
It can go through objects too, because it's a pressure change, so it can go through objects.
That wasn't the best example for that, but I understand where they're coming from. Are we doing show and tell, or do we have questions here?
If you want, I got a few more questions if you don't mind.
Sure.
We'll catch up on them, and then so Pilo 1408 says, hold on a second. I don't have the keys. I think I hung them up. No? Gotta go get the key. I don't have the keys. Pilo says, so they can show something being brought over the horizon with zoom, utterly fail, and yet don't reconsider for a moment. Peak flat Earth.
I reconsider constantly, to be honest with you.
I'm not joking. I've never seen anybody bring something back that's gone actually over the horizon with zoom. I've seen it like Dearth showed, too small to see is not over the horizon.
I understood your position on that argument way quicker than Cracker did, and I was just like, no, it's not. None of the way he's arguing, he's right. The way he said it is correct. Not gonna work, man. The way that we argue it isn't gonna fly. I think when you argue that it's never actually below the horizon, regardless of what you can see. Fair point.
All right, now I am going to disagree with this particular one. I'm not afraid to do that. Timbo Turtle says, why is the moon upside down in Oz, Australia? And that part I'll disagree with. And then he goes on to say, and I can't see Polaris from Australia, and the sun set south of west. So if you use the AE map, the sun could never set south of west. It always must be north of west. He can't see Polaris. But here's the one I take umbrage to. He says, why is the moon upside down in Australia? Actually, the moon being upside down on opposite sides of the moon on flat Earth would work.
Right.
What would not work is how much or what portion of the moon you'd see. Because
it
if
should
you
be
have
not the face that we see all the time. It should be the other side, right?
If this is the moon and you're over here, you should see this part of it.
But we all see that.
And if you're over here, you should see this part of it. But we don't. We all see the almost identically same part of the moon.
Matter of fact, we only ever see that no matter where on Earth we are, right? Isn't that weird for a spinning sphere that's phase locked, apparently?
It's tidally locked, yeah.
Right.
We see about 59% of it because it has a little libration.
But it would never any more or less than that. Isn't that curious?
Not at all. That's actually predicted. Because if the moon had a homogeneous distribution of mass, then that would not happen. But because it's not homogeneously distributed, then it over time gets locked in.
most flat earthers assume the sun and the moon is the anode and cathode of the Earth energy system and are not physical objects, but are reflections or projections from somewhere else. And that's how we see it, the same face. That's our explanation.
That's not explanation. That is a hypothesis that has not been confirmed.
Correct.
It's not even been tested. I mean, we could test it right now, and it doesn't pass tests. That's the thing.
How would you test it?
Test that it's a cathode and
That
anode.
it's not a physical object. I mean, do you think we went to the moon?
Yeah, people landed on it.
For real?
Yeah.
All right, not gonna touch that one.
But also you can bounce radar off of it.
Right. That was the same experiment,
Right.
same people, same storytellers.
You can do it yourself if you have a ham radio. You could go find somebody with a ham radio and you could talk to them about it. The challenge is, if you ever talk to somebody about ham radio that has ham radios, the challenge is to get them to stop talking about it. Right? People in the chat, am I right? Also, you can see the shadows on it, which don't happen on
The craters, yeah, we know, we see
which
them.
don't happen whatever non-physical thing. Indie Tiger Sci-Fi Review says, why can't we see Alpha Centauri, the closest star to the sun, in most of the northern hemisphere?
What constellation is that in? Do you know? Which zodiac rather?
I'm not much on zodiac. I was never into astrology.
Right.
Alpha Centauri is in, where is it? I'm sure somebody it's in the constellation of Centaurus.
Gotcha. Centauri.
I'm sure somebody in the chat's like, oh, he knows it.
Nailed it. So why can't we see it from where?
Southern hemisphere. Or sorry, he said northern hemisphere. Most of the northern hemisphere. If there's nothing in the way and it's very far up, then there's nothing blocking it. It's not like it's the why are things being obstructed bottom up over water doesn't have a plausible mechanism, but this is much worse. The stars, whatever explanation, I've heard many different ones, but what is the explanation for it? Don't know. But that why you wouldn't see it. The stars are obstructed bottom up too, the entire star field.
I mean, if you're looking out from any point on the Earth, you're always looking south if you're looking away from the center. So then the stars, as they rotate, you wouldn't see the ones that are way behind you if you're looking this way as they rotate in front of you.
Turn around, look in all directions. Why, if it's up there, if it's a dome, a firmament, if it's a celestial plane, if it's whatever, they're up there somewhere. And there's nothing in the way, and it's not even close to the water.
Can you see 100% of the sky at all time? Remember we went over the zodiac and how this should be the bottom. So if you, do you see this?
It doesn't matter. There are stars you cannot see at different points on the Earth, even if you rotate all the way around 360 degrees.
Yeah, the Southern Stars one is something I'm not 100% arguing for. The Eric Dubé explanation doesn't sell me, like I said. Not sure on that one. Fair point. We'll figure it out and do some experiments to get back to you.
Heard that before. All right.
Have you?
Hilo 1408 says, claims to know the globe, has no idea what Coriolis is.
No, we're well aware. We just don't accept it as the
Cracker.
force for all the stuff that we argue that it say that it does, right? We know what it is. We just argue that it's not the force.
He didn't know that it was directly proportional to your velocity in relation to the surface of the Earth. He thought that if you threw a ball up, Coriolis would make it go flying 1,000 miles an hour. Coriolis is a very weak force, and it's directly proportional to your velocity in relation to the surface of the Earth. If your velocity is 0, Coriolis is 0.
You thought that firing a bullet is unaffected by the Coriolis, and toilets spin either way, and then storms appear sometimes to spin counterclockwise in the southern.
I've still never seen one that didn't match the Coriolis.
I'm gonna find one of those examples and email it to you after we're done, just because I know I've seen it.
I'd love to see it. There may be a couple, but there's outliers to everything.
Well,
Nothing is perfect.
in that example, though, it will have to be that way because of the Air Force and the low pressure and the high pressure. They wouldn't make any sense for it to be the opposite in the southern hemisphere, would it? I wouldn't find a rational explanation in that model.
Air pressure doesn't explain the rotation. All right. Chronic Avenger says all observations need to be explained, not just the cherry-picked ones.
Okay, I agree.
Miles Wilson says occasionally hurricanes that form at the equator will randomly rotate in the wrong direction, just as would be expected, but this is rare. So there we have Miles.
They migrate also.
I don't know. Miles is backing on that, but there's Miles from the audience says that they will randomly rotate in the wrong direction.
He said not to worry. That doesn't prove you're silly flatter. Got it. Got it.
I'm gonna read this one. JRock69 says, sorry for being annoying, Toon. Don't have to read. I just read it.
That's a good thing.
Rags. All right. This is for Cracker. Rags was not a Cracker fan. Says, I amend my previous super chat. Cracker is clearly the worst of the two. I have extra letters, so everybody should watch Excalibur from 1981.
Was I the worst before that, or was there a running joke I'm unaware?
I think he had previously said that it was a competition, and so he amended it. Cracker is definitely. And
Who was the previous?
I will back that. No, it was a big competition between you and Cracker.
Oh, okay, I got you.
And Cracker won the award you don't want to win.
The asshole award. Got it.
All right. JRock69 says ballistics arc app. I shoot with it every week. And I have
For the Coriolis on a bullet.
yes, and I actually have. Let's see. I'll share this to you so you can see it. The Coriolis force. There are quite a few different ways that snipers and other people that need to take it into account. So I'll show you here. So there it is. Coriolis for long range shooting and Coriolis for artillery. So this long range shooting. So here's just several examples. This is not exhaustive, but it's a good list there. We've got this particular software from Dexidine.
And this what loads onto your gun and affects your reticle when you're aiming, or how does this interact with the gun?
I think this particular one is an app that you run in like a handheld computer
Concurrent with the weapon, or
yeah. And
is it integrated?
Here's a book. Chapter 7 covers Coriolis applied ballistics for long range shooting. Here's a video for people that like videos by Brian Litz, the author of the book that's listed above. Talks about it in this one. We've got an article on Coriolis from the American Shooting Journal.
Mm-hmm.
Now we get some of these interesting ones. Here's a computerized scope. So you put the scope includes Coriolis adjustment inside of it.
Mm-hmm.
Right there. You can turn off on or off corrections for Coriolis in the scope.
Boy, my mind got blown. Proved.
Here's another one. This looks like, it's a Nomad portable computer here that you run the software on. Here's another portable computer that people use for calculating their firing solutions. Correction for the spin of the Earth. Operator inputs the latitude of the globe and the direction of fire from true north. So there you go. There's several different solutions for including Coriolis when doing shooting. And then they do it for artillery as well. This is from a Mark, a 50 caliber gun, 16 inch gun in 1941. These are the range tables from the Navy, and includes curvature of the Earth right there. And it includes, I think I closed it.
Oops.
And it includes, let's see. There it is. Effects in yards of range due to
For
rotation
latitude,
of the
for
Earth.
arc. Look at that. Is that in feet? What are those numbers? Is that
So it's effect in
Look a little
yards.
bit.
So yards. So there's one Coriolis or it's often called the Udvush effect, where they will increase or decrease the amount of
So at
the
latitude
range.
48, it's 40,000 feet for the Coriolis effect, for yards rather.
No,
For,
where are you seeing that?
48, the second one from the bottom in the first quadrant, in the first where it says 48, 93, 131, and in the middle is 40,000. The one above where you're at. I
That's
think,
the
yeah.
range. So if your range is 40,000 yards,
Oh, that's
then
not, yeah.
then the adjustment is these smaller numbers on either side of that center.
Gotcha. Interesting.
So the Navy uses it.
They also use a whole bunch of documents referring to a flat, non-rotating Earth.
Yeah, I've read them. I don't think you have. I read them
I have.
all.
Well, I
Read
found the
all-
citation.
All 44 of them I read and put on my website, mctoon.net/gov docs. All four. It was a massive
Boring,
undertaking to
dry
go read
as shit.
them.
Are you saying that the bulk of it doesn't? So I don't know what's your rationale for them starting out like that.
It's part of engineering that if you are specifically not including something that matters, you need to tell the people that are going to be reviewing your stuff later and using your stuff later that you did not include it. So when
Gotcha. Fair enough.
because in order to include the rotation of the Earth, you just saw the tables that the gunnery used. So if you're going to do something for an airplane, well, you need to have calculations based on the velocity and the
right, so
latitude.
You're saying the
they're-
baseline is the.
Yeah, they're like, well, we're not going to include that. There's other ways to do it. People have done it in other ways. So don't forget to do it if it matters for your particular application.
That'll work for every document that ever crops up, and doesn't it? That's why every time that could
The
be the
reason
explanation.
why they specifically say that is because it matters, because it's part of it. And if it didn't rotate, they wouldn't mention it. It is actually an engineer reading that says, oh, that those flat earthers don't understand what engineering is. So
That's an interesting answer. I accept that.
Mr. QTube, first name Fa. If you read that out, you'll get a different message. Says 15 degrees per hour. Thanks, Bob.
Okay.
You know about Bob.
I know all about
And
Bob.
his 15 degree per hour drift. Good old Bob. My take on Bob was the way he came at it was anti-scientific. He's like, we wanted to prove the Earth isn't rotating. He stated in the documentary that his goal was anti-science.
A
He
lot
wanted
of
to
people on
prove
both
the
sides
opposite
start
of
that,
science.
right? They get so grounded. They have the preconceived.
They do,
That's what it is,
absolutely.
right?
And I completely correct there. Then they measured the rotation, and he says, and this is key, we weren't going to accept that.
That was that documentary that came out that they banned you from.
That's the opposite of science. Science
Right.
is you follow the evidence. If the evidence
with
says that there's rotation, then you say, well, the conclusion is that there's rotation. Let's test it again in a different way to see if there's something that we missed that caused that result that was unexpected.
Right.
And he did that. He encased it in something because he thought the heavenly energies were doing it, which makes no sense, but fine, it's something you could test. He encased it in something to block what he thought were the heavenly energies, and they got the same result. So I don't know if they ever did test it inside a bismuth chamber, as he talked about.
There's so much crap and misinformation out there. Stupid people make smart people look dumb.
I don't know. You guys don't need help. Okay. Jolene says, shameless plug. These two encouraged me to create a /memes are not evidence on Reddit. Bring on the stupid. Please ask them the steps of the scientific method.
Oh, I have all your memes for you. I'll share them with you. I got a couple.
No, I don't want memes.
Really?
So I I'm not a fan of this, but she says ask them the steps of the scientific method.
Mhm.
Do
You mean me? Right.
Yeah.
Let's see. We got, what was it? Repeatable. Ask a question, do research, guess or form a hypothesis, test experiment, judge a procedure, decide whether you got to do more data, carefully check, or whether you want to proceed to the, let's see, analyze, draw conclusions, form hypothesis, and then communicate results. All the
There you
while
go.
going back to if your results vary or variables change.
Yeah, so that's and that's only ever a guideline. It's not a here, I'll show you.
I'll send you the meme. You probably like that.
I've seen the memes.
Have
So
you? Science
here
worshipper
is
one?
I've been on Facebook. I mean,
I'm not allowed.
You drown in memes. So here's from Berkeley. On how science works, and here's the scientific method. One serving. It's on a note card there. Ask, right, and here's the 5 steps. Sometimes people have 5 or 7 or 8 or whatever. It's too simple. That's it. It's not a formula. It's not a rigid thing handed down by God.
Doesn't allow deviations and crazy new data or whatever as you go along.
You figure it out, and you use your brain and logic and deductive reasoning and inductive reasoning and to come together to formulate something that makes sense. You write about it in the end, and other people can come along and evaluate whether or not your reasoning made sense, and they will do their best
Judge, repeat, replicate. Right. That is what it is.
And in the scientific community, if somebody publishes something and you can come along and refute it, you get all their street cred.
But the peer review process just means that everyone who has the same idea assumes they have proved their new ideas, and they disapprove everything that they disagree with. Isn't that the fault of that method?
The peer review is the opposite of that. The people doing the review, they want to ruin you. If they all believe, if they can, right? If they're like, well, I don't like what this guy is saying, I'm going to refute it. Or I'm going to come along and right, somebody got something published. Like, hold on a second. I think that's wrong. I'm going to go publish my analysis of this other experiment or write-up or paper, and I'm going to tear it to shreds. That happens. People do that. Or I'm going to do another. I think that he missed something, or they missed something in this particular experiment. Their methodology was junk. I'm going to do it better.
Right.
That's the beauty. Like I
so
said,
if that second guy, right?
Down.
If they prove it wrong and then that gets peer reviewed, which method is then the shining example to go forward, right?
Well, now you've got 2 in conflict with each other.
Right.
What's going to happen? People are going to get interested. Hold on a second.
You think that happened more often, wouldn't it?
Maybe it does happen. It does. It absolutely does. We just don't see it. It doesn't make headlines unless you're in that particular field. Right? If you're in that field, like, oh, did you see that thing that Bob that published? Oh, I can't believe that. That was so dumb. I'm gonna write my own thing. I'm gonna get my collection of people together. Hey, do you want to? All right, we're gonna write something, and we're gonna tear apart what he did. We don't see that. We're not in that field.
Right.
So the process of science is iterative.
Right.
Science investigates question at deeper and deeper levels. The process of science is not predetermined. So when Cracker was trying to tell me that I must do it a certain
this way, so I can laugh at you, right? I get it.
And he's like, well, you need to have an independent variable that blah, blah, blah. No, it's not predetermined. I'm not.
I honestly, I like your method of just this one little facet, exclude everything else. Let's argue this on its face, and then we'll move on. And no more complications, no opinions, no suppositions, just this one. Okay, now this one. That's kind of a neat way to look at it. And it kind of changes the way you argue and think about it when you're trying to argue from that perspective. Well, wait a second. I was including gravity and this other crap. Hold on. Let me rethink it. Okay, now, right?
Yeah,
so he already had his gravity determined in his calculation. So when he removed it, he was like, I don't know what to tell you.
And then iterate. All right, let me stop this share here.
Do you ever see that rocket they launched from Arizona that supposedly hit the firmament?
The Go Fast rocket
2014.
There's a
you don't like that?
yo-yo D-spin on that. Did you see that?
You know that they saw the moon from there, right? When they hit the low orbiter from Arizona, they saw the moon over New Zealand.
Yeah, it totally matches.
What?
Yes. People have...
It matches
Here's what happens. Here's what happens. Somebody sees a meme, like you maybe saw a meme, of, well, how could they see the moon from here because it was here? But there's no analysis provided in the meme. That's why memes are so deceptive. There's no analysis. When you go and do the analysis of where the moon was at that particular moment and where it should have been seen at that particular moment, according to the globe, it totally matches.
Where did the globe say the moon was?
I don't recall exactly. I've seen
Somewhere
that.
visible,
I've
obviously
seen
from Arizona.
Yeah, I've seen the analysis. And Arizona and New Zealand are not that far from each other. One's the northern hemisphere, one's southern hemisphere, but Arizona is somewhat west and New Zealand is very far east, right? They're both...
Wouldn't that be opposite sides of the globe almost?
No, because
Or near enough?
they're both actually kind of close to the international date line. Arizona is maybe 6 hours away from the international date line, and New Zealand is like 2. So that's, I don't know. It's a rough guess there. 8 hours difference out of 24. Well, that's not that far apart. And about half of the Earth should see the moon at any particular time.
All right.
Right?
Except when it's transparent or not there, right? Or the new moon cycles when you can't find it for 3 days.
Yeah, you can't see it unless you get good. I mean, you can if you're good at photography.
Really?
And it's never transparent. It's never... Nobody's ever actually seen stars through it.
Really? So everything I looked at was a fake meme then. That I saw the videos that showed that because I didn't test that one myself. So
You've never seen a video of stars going through the moon.
I've seen many, right? I also thought I saw it in my real life though, but I haven't proved it or tested it or recorded it. No, you've never. That's something that.
So there's a challenge. I have $10,000 in escrow, and I have a one challenge from that to do celestial navigation based on flat Earth, and show the process.
That's a silly, but we don't believe in there's no space for other planets or other places to go. So celestial navigation is a moot concept to us. There is only the Earth to us.
But sailors have used it for centuries to accurately get their position.
The stars.
And there are some flat earthers that claim that it only works on flat Earth. So my challenge is especially to them. Well, go ahead, show the process. And it was 5 months ago. It was in February. Nobody has done it yet.
We will never prove that we're a disc in space because that's stupid.
Right? All right.
Oh, what's up, kitty?
Here's Turtle. Turtle's been handed to me.
Look, you need some attention, huh? That's what's up.
Well, I often am handed random pets to present on screen. So there's Turtle.
I need the spotlight. That's what I need.
All right, there you go, Turtle.
That makes sense. So,
all right, so 5 months ago, I did that. Well, the same money in escrow, I want to write up a challenge to, what was the topic? Oh, stars through the moon. So a video.
What would qualify as proof for that? A video?
Well, so the challenge is, writing these challenges is not actually difficult when it comes to having the flat Earth present evidence for it. The actual challenge is globers
Prepare
that are
for all
smart,
stupid.
trying to game the system.
Right.
So what would it? I would expect to see stars where the outline of the moon, where part of it is dark because it's in that phase, and then a star just going through it the whole time. And the star, all the stars are named, so we would obviously know the name of that particular star, and it would need to be over time, so not one single photograph. So there are photographs where it looks like it, but they're just dead pixels on the camera.
There's time-lapse video, I think, right? Let's see. I think I have one right here. Or I have one. Let me look at it again before I show it to you.
No, show it first. I want to see it.
It's 17 seconds. It couldn't possibly be wrong. Let's see. Is this a time lapse? Is this a video that's just a series of photos? No, it's just using different filters. Well, I wouldn't hang my hat on that post. 2 minutes.
Filters, like digital filters in post-production.
Or no, it looked like they just had to move from like a red filter, a blue filter, and then a
Oh,
what do you call it? The clear one. I think it's to show the contrast.
all right.
There we go. Mm-hmm. Yep. I mean, it's only the series of stills, so I guess we're not going to go with that one. That's something I can.
I'm sad to report that Effed Up World has lost his moderator status. At least for now.
How do you piss you off?
Effed Up World, he's the flat earther. He's putting links to his own stuff in here.
Ah.
Because you can't post links unless you're a moderator.
Oh, neat.
and so he can post links because he was a moderator. And like that's not really what it's for. But anyway, Joe Hill, Joe, make your case if you want to get it back. So
That's neat. You got a good team, man. You got a lot of people working behind the scenes. You got your groove carved out. I think I saw when you started, right? Not that long ago.
Well, it was 3.5 years ago. 2018 was the first time I participated in an online forum on this topic.
Oh, right. Your channel's 2011, but you weren't doing this the whole time.
Oh yeah,
Then you would have chosen a different name.
2011. Yeah, so it's actually my at college I was in a rap group with a friend, and MC Tune, like MC Hammer, was the name I chose. It's a joke. I mean, it's not just invented out of nowhere, but yeah, I my middle initial is not C. Anyway. So, all right. Jeffrey Hollambake, I think, sorry if I got that wrong, says, I demand proof that Cracker actually denies the Earth is a globe.
What form would you like it? He'll write you a letter, give you a stamp, and 2 middle fingers, probably.
That sounds about his style. Harold, in all caps, oh, this is awesome.
Oh,
Says,
no.
can you show us a bucket of gravity in a lab to prove your globe?
We don't believe in gravity. That makes no sense.
No, this is Harold, who's channeling his inner flat earther, specifically DMOC, who has asked that. He wants me to show a bucket of gravity in a lab.
That's what I mean by people just making us all look dumb.
He's one of you. Saying.
Hey, listen, we're all
and I just so you know, we don't want him back. He gets to stick on your side indefinitely. LB stuff things and more. Things, stuff and more. Mostly things, but also stuff. Says, I think there's hope for Shane. Just study up.
I did study up, man. I mean, we don't reverse what you believe with nothing. You go through a whole, it took me like 8 months before I was like, I'm not going to tell him. I'm not going to, oh my God, I think it's, no, my God. No, it's crazy. I could have went down the crazy hole and now I believe in nonsense, but it really, as most people argue, has no impact on your day-to-day life. So strangely, I can manage it and still live.
So mute donkey says, we all know you would have gone with DJ Truth.
If that was your specific flat earth debunking channel as opposed to
no Badger's Law, look it up. Badger's Law. All right. JRock69 says, world class sniper, make me a mod. Well, I happen to have an opening.
Oh, you're right.
He is now a mod since I have an opening.
Look at that, dude. Serendipity alignment.
I've just demoted. I mean, there's no limit. Liquid Flame says, I feel warm and welcomed by that t-shirt. I think he's talking about yours.
No one read it.
Yeah.
I got a better one for COVID.
Serafino says, please explain why Rocky Mountains and tallest mountains around the world disappear while flying 34,000 feet above the Earth. If it's flat, only explanation is globe.
What? The mountains disappear?
So yeah, so if you're flying in an airplane 34,000,
Right, cruising
35,000 feet
altitude-ish.
high, higher than those mountains, the Rockies, why would they disappear?
I mean, I think they would just fade away the same way the sun would fade away on that perspective line as it looks like it's setting as you go away. The mountain would just recede into the limits of your ocular perception until you can't see it anymore. It doesn't really go away. It would have to recede forward over the ball for that to make a sense.
But why would it get obstructed bottom up? All right, J Rock 69 says the Rockies are actually flat. It's perspective.
Thanks for that. I hope you paid a bunch of money. Get that one up there.
Oh, this is good. So when we were talking about gravity, the most ridiculous one is incoherent dielectric acceleration.
That's made up nonsense words. Come
It
on.
is. And to that topic, remember when Whitsitt said he believed in Tesla's dynamic theory of gravity and then admitted that no one knows what that theory is?
Funny thing, I saw that guy. I loved him. I saw him on your show. I lost a lot of respect for him. The only thing that happened at the end of that, I was like, what the hell happened to you, dude? I thought you were smart. What the fuck are you doing? Man.
I like poking at him. He lies a lot. He never backs up his stuff.
You guys seem to have some history there too.
So I have this. This is the Eclipse Almanac 2021 to 2030. This is a prediction of the eclipses for this decade,
Right.
based on VSOP 87 and ELP 2000, which is geometric models of the Earth, Moon, Sun system, as well as
It's based
solar
on the
system.
sky clock that we've been using for everything, right?
No, it's not. It's actually based on the positions of the objects in the solar system. That's what it is.
Right.
You can look up VSOP 87. People can. It's been implemented in Python. It's open source. People can look
But
at it.
the Mayans predicted every eclipse 1,000 years ago without any of that. I mean, the
No, they
sky
didn't.
is.
No, they didn't. And that's what Whitsitt said. And I said, give me evidence for that. And he couldn't. So don't say it, because you know you don't have it.
I know you. I know your style. I'm not going to venture a
Right?
hypothetical guess
But-
as easy as I would
But
before.
here's this how specific it is. The location. Mayans didn't have location. All they had was a sorrow cycle, which is a numeric sequence, not
There's
based
that
on any
12
geometry.
Hmm.
So this right here this is where it will be seen and what time it will be seen.
But
No,
we've been predicting that for as long as we can record stuff, no? Or is that we claiming this is a recent 19th century development that we can now predict eclipses?
this is completely based on the geometry of the solar system.
Then how do we do it before that book was published then?
Well,
They
there
looked
were
at the
models
sky, they measured
before.
it, right?
There were models before ELP 2000. So the eclipse of 1918 was the position was accurately predicted in advance.
Aren't they all?
And before a certain time they weren't, because the positions of the Earth, Moon, Sun are necessary to be plugged into the how it's done. So the 2017 eclipse was predicted ahead of time using a geometric model of the Earth, Moon, Sun and the solar system in general. There's two separate parts. ELP 2000 is specific for eclipses, and VSOP 87 is a geometric model of the solar system.
So if we remove the Mayans, was there no other culture who could predict the celestial movement of the bodies and use it to predict eclipses? Or did I make that
all
up?
they got was the approximate day. That's it. It wasn't
All
even.
the
It wasn't
Mayans,
even correct.
Aztecs, Sumeria, all that? Really?
That's all they ever had, and it was not a geometric model. It was simply a repeating numerical pattern that they identified about an 18-year numerical pattern. That's it. There's no geometry to it. And they didn't know where it was going to be, or even if it would happen, because sometimes it doesn't happen because the shadow doesn't fall on the Earth. So
Yeah, I haven't heard those arguments before.
so
I'm gonna have
anyway,
to do some,
I intend to have also a challenge to use any non-globe based model to predict an eclipse, but we know that's not going to happen.
That might be rough. You know, David Weiss has a similar strategy and a mountain escrow to show people with a proof of a globe, right? You guys should do a show together. You'll pay each other.
The difference is that he does not have the money in escrow.
That's true. You're right.
He does not have clear, objectively measurable criteria. What does he ask for? What does he ask for?
Proof to his satisfaction subjectively is what he asked for. Kind of goofy.
Well,
you prove it to me.
To his satisfaction. That's not. How do you do that? We know going into it, he will reject everything.
That's what I thought. Arguing the other side when I heard him, I'm like, well, listen, man, I know you say that, but
there's four things that I think, and people could disagree, but I've not seen disagreements. That four things I think for a challenge to be legitimate. Number one, the money has to be in escrow. And there are globe earthers that have done this and not put money in escrow. I don't back them. If the money's not in escrow, don't come to me. Number two, clear, objectively measurable criteria. Right? Predicting an eclipse location is objectively measurable. Right? You say, well, it's going to be seen at this position. Okay, let's wait until that day happens. Was it seen there? Oh, that was objectively measurable, right? Non-changeable criteria, because I did a challenge right here on the wall. You can see these maps up on the wall. I did a challenge that was to a $100,000 challenge by a guy named Flat Out Hero, who said if you can do 3 legs of an airplane flight and wind up where you started, and at each corner there's 90 degrees. Did it. Multiple people did it in software. He said, oh, I meant using paper flight charts. So I did it with paper flight charts.
Why would a triangle not work on a flat surface again?
3 90-degree angles to a triangle. Remember that planar triangle.
If you go the same amount in every distance.
60, 60, 60. A spherical triangle has more. Right? Here's a planar triangle.
Right.
A spherical triangle, like on the exercise ball, you can have 3 corners that are each 90 degrees. Right? I mean, anybody can test it by just drawing lines on a
For sure. I mean, the practical model of a triangle on a sphere has little practical application outside of proving the globe in my mind. Like, what else would you use it for? No need to
navigation. It's a very important part of navigation.
But are we assuming you can't navigate by the stars on a flat Earth? They've been, look up, go north.
That's all. But that's not actually anything about the geometry. So there's you can't do any celestial navigation, presuming flat Earth. There's no, you can't do anything. You can't get your position. Right, navigation, you need to know your position, and then you need to know which direction to go, and you need to know the distance so you can plan your route, right? So you're going on a ship and you're slow, like Columbus days, you want to know how much food to bring. If you're going on an airplane nowadays, you're going to want to know how much fuel to bring. Same thing for a ship.
But the sky is the same on a flat and a globe Earth. The sky is the sky. We see what we see, and they've been using that to navigate, however you want to call it, before they figured out the mass of the sun and the Earth radius, right?
Celestial navigation absolutely relies on the Earth being a rotating sphere, because the positions of the stars are moving over the Earth, and they're plotted in a celestial sphere. So if you see a star and you know what time it was, then you know what point of the Earth it was above, because it's from a celestial sphere onto the sphere of the Earth. Then you need to know your distance from that spot, and the distance really is a problem because if it's flat, the distance is going to use a planar formula, like Pythagorean theorem or the polar distance formula. But if the Earth is spherical, you're going to have to use a spherical trigonometric formula, like the Haversine formula. Which one works? Well, when we do celestial navigation, we use the Haversine formula.
They look up at the stars and they gauge their position and they travel in a direction based on what they see. Isn't that the same on either model? They were doing it for You're saying that until we know the Earth is spinning and round, we can't look at the sky to gauge where we're at and where we're going?
5 months and $10,000 still sitting there unclaimed.
You know, have you seen Weiss's app, right? His model of the sun and the moon and the zodiac and everything spinning
Yeah.
on the circle with
It's
the
on my
Tropic of
phone.
Capricorn. Is it? Do you really have it? Did you get it to just debunk it or to check it out? Or did you pay him $3?
No, I did not pay him.
That's funny.
I
So you know
think
that-
I got it. I got it before he was charging for it. I think
Honestly, I stole it. I didn't tell him
So-
that, but whatever.
that's fine. I won't tell him.
You should do an interview with him, man. I think
He
would you
won't.
be willing? Would you be
Oh,
willing
I
if I
keep
can get him?
challenging him. I've challenged him over and over again.
If he can do Professor Dave, he should do you. A lot of people compare you. I'm like, but he's polite. He's arguing to say, but he's not an asshole. He doesn't interrupt. He doesn't just yell. He doesn't demean. He doesn't attack. Seems like he's arguing his point to his satisfaction. That's different from this dude, I think. But I mean, I think Weiss would. If I can get him to debate you, would you do it?
Absolutely.
Word, I'm gonna try. I had him on a couple times. That's what I'd want to see.
All right. Somebody said, all right, let's see. To be fair, all right, Earthrise. To be fair, I think Effed Up World is trying to show me something about a debate. I hate advocating for the flat earther, but all right, Joe, Effed Up World, let's talk after. It's not an absolute decision. You can get it back.
Don't post Linktree in my chat, bud.
So, all right. Lael says the globe does not say anything. Astronomers who make measurements. Second. The globe does not say anything. Astronomers who make measurements of the stars.
Is that the navigation issue still?
I think it's a little. I'm trying to understand it, trying to interpret because I think it's not quite written well. Lael, what tagged me with what you meant so I understand better. Sorry, I don't understand what he was saying. All right, Manny Karen says, how the actual F do you regurgitate math?
You get told a squared plus b squared equals c squared, and then you tell teacher a squared plus b squared equals c squared, and then
No,
you get a cookie. That's what
you apply it.
you learn a formula that you apply to the same variables no matter what, right? You interchange, you add a number, the formula is the same, the
Yeah,
structure never
and-
changes, and you regurgitate it with anything they want as the variable.
You apply it. Yeah, you have to work though.
You can apply it, but you can also just use the same principle to say this, like the proofs, like algebraic proofs are a good example, right? Here's something I already know. Here's all the math that shows that it's real, and I proved it, right? What do you like?
You can do proofs in math.
Right, for sure. But you could also use the model, then you can apply the model in, say, engineering. You take that theory, use it to make a building, and you draw your plans up. Different. Do you think that our education system teaches people to critically think or to regurgitate what's in the textbooks as a general basis?
I think higher education teaches you to critically think. I think elementary school, middle school, some of high school, depending on where you're at, is a lot of learning by rote. But once you get the foundation, then you can start to do the critical analysis. And being a homeschool parent, it's something that I show my kids as they're getting into high school. There's this, I forgot what it is, a pyramid or a triangle of learning things, applying things, critiquing things, tearing things apart, right? That's this hierarchy that you work up. So by the time you're in high school, you should be doing the not just the analysis, but like starting to critique things and having your own opinion and finding things that's wrong.
Yeah, I think your method is way better than either method. Homeschooling the kids is definitely the way to go. I think they are definitely being taught to critically think as they go. I would hope.
I look, it completely varies. I know plenty of homeschool parents. For the most part, the ones I know are pretty good, but there's certainly plenty of homeschool parents that are just teach by rote and that's it. They don't get into any application.
Huh.
So Professor Phil Bell is wondering, which map do the very expert flat earth navigators use? Is this the same map secret used by airlines and shipping companies?
This map right here, yeah. I mean, the map is the map. What's it? The new standard of the Gleason's map, probably the one on the UN is the most accurate distance-wise to
I-
plan.
So Professor Phil Bell lives in Australia, and I think he's going to have take umbrage with you saying that Australia is shaped like that map says.
Well, what about all the various globe pictures that have the various dysmorphic continents and half of America missing, and all the clouds copy and pasted, etc.
It's a different topic, but it's not a good one. Doesn't work for you. But why would the Gleason map, which right on the front says that it's a projection from the globe,
It says that for sure.
Projection on it, and in the patent application it says it's an excursion is the exact word that it uses from the globe.
It does say that, but nonetheless, that's the map I would use to answer the question.
But the distances don't work.
From Australia to
Navigators
where?
don't use that map.
They use, let's see, this one, the Gleason. Nope. I think I have all of them.
You're gonna say the new standard map of the world, which is still an AE map, just like the Gleason map, the air map of the world from 1943, which is just an AE map. They're all just.
I have
an
that
AE
one.
map.
That may have been on my list.
The actual air map of the world has a scale on it. If you look at the scale in the lower right-hand corner, it shows you that the distances between longitude farther south are smaller,
Right.
just like on a globe.
I think that we have no 100% accurate maps on this whole Earth. Of
But-
where
Yet airplanes get where they're going.
Sure. Yeah. I mean,
Somehow
you don't need the,
navigators figure it out. So
only
somebody's
from the
asking,
spinning globe.
Henry Lemieux says, do I live in Minnesota? I do live in Minnesota. All right.
Oh.
Geistview says, does he think that south is down on a sphere?
South is every which direction away from the center. That's the easiest one that works on both models. That's a silly argument. Not to pick at it.
At least get it right. Good job. How does he expect to account for Earth curve to look like Earth curve is not a hill? So this might be
don't
a little
account
more
for curve
towards
at all.
cracker, but
Yeah. Even the globe model says you can't see the curve and it's an optical horizon. So technically no one ever sees the curve, right? So that's a silly argument too.
well, if you're close to it, it's very difficult to see. But if
As
you're high,
what-
if you're up high enough,
Neil deGrasse
40,000
Tyson, you can't see it from a beach ball. It's right here, right? That one.
he's wrong. At 40,000 feet, if you're like in the cockpit, you could see it because you have a wider view. You could see it. 45, pretty good. If you're at 60 or 70,000 feet,
I think Google says you can't see the curve from that height. The cruising altitude of a plane. It's only through the windows that are,
yeah,
what do you call it, circular.
The side windows at 35,000 feet. Just you don't have enough width to your view.
Correct. So then, when do they think we see curve?
120,000 feet, you always see it.
We
Dwayne
don't from
Kellum.
anything from NASA.
Dwayne Kellum, he's a flat earther. Dwayne Kellum sent up a balloon with a rectilinear lens, a Sony E50, 50 millimeter lens.
It's Dave's wife's Zoom background, right? Or, oh no, you have it there. Let me see. Did you show it? Did I miss it?
I didn't do anything.
Oh, all right.
All right. J-Rock, the sniper again, says we don't use firing bullets as much. Wait, we don't use firing bullets as much we could. Mod me. As much
Good
as
comment.
we could.
Good contribution. I agree.
I hope J-Rock has had a little, had a little to drink maybe. J-Rock says, sorry for being annoying too, and don't have to read. And I did read it twice now. Indie Tiger Sci-Fi Review says, what is the center of gravity?
Well, we don't believe in gravity, so nowhere. Unicorn, fairy tale land, the center of gravity.
It says V. The V is the center of gravity. Must be a joke I'm not getting. So
I'm like, I can tell you where the center of magnetism is.
in no, you don't know, but the center of gravity would be like the middle of it. Often it's more recently used termed the center of mass.
Is that the molten supposed iron core that lose somehow at molten metal temperatures, loses its
any
magnitude.
particular object has a center of mass. Any object, like an airplane or a sphere or a Rubik's cube. Pat in the chat says if the Earth was actually flat and non-rotating, the military documents would not specify it. It would just say Earth. And that's
No
it.
rebuttal.
And that's what non-engineers have a problem with. Because the other things in those documents tend to say things like a rigid plane. Well, airplanes aren't rigid. Non-changing mass, a consistent mass of the airplane. Well, they use fuel.
So the baseline is the most uncomplicated, non-variable one. To
Yeah,
then
they
can
start with
apply
the baseline, right? Because if you're going to do a mathematical model of an airplane, do you need to include the mass, the varying mass of that? How
keep
could
it
you
the
possibly
most
include
basic,
that?
right? Yeah.
How could you possibly include that in a general purpose calculation? And I love this one. No wind.
Right. That means
no
I'm going to
wind.
claim that we don't have wind on Earth. I got you. I got your argument.
Exactly.
That makes sense to me. That works for all the documents we'd ever find.
Right. David Ulmo says, I think you might be getting through to him. Hope it sticks.
Oh, I mean, I started where you were, man, but I'm undecided. Right? If I learn stuff, if I get taken up in a rocket to go to the moon, you think I'm going to disbelieve the moon is real? Come on, take me up. Let's go.
If the sun's in the clouds, just go take a helicopter. It's a helicopter, and then get like a bucket on a string and scoop up a little bit of the sun.
There
Right?
are lots of people who got close to and supposedly over and took a video. It's a completely crazy perspective, man.
I want to see that scooped up bucket, man.
What about the sunspot that it makes on the clouds locally, where it's a little bit hot right below where it is?
Just a reflection.
Refraction. I got it.
No,
my bad. That makes
reflection. Reflection. Dude, lay a mirror flat on a piece of paper. Put a flash.
I'd use the same argument for the Antarctic sun, right? The reflector close to the edge.
All right. Bendova.
I like that
I
name.
think there may be a double entendre in his name. His or her name says sweet haircut, looking very swish.
Yeah, I was gonna say that's a hell of a choice, man.
I did that today myself. I seriously. Right out here in the back of my house, there's a plug-in, and there's a little box thing in the back of our house, and I leaned up the mirror there. I brought the clipper out and I did it. I can't see the back. I walk around. My wife's in the front. I go, hey, how's the back look? She's like,
good luck.
I'm like, what's wrong? She's like, well, you got this. And I'm like, all right, hold on, come back. She's like, all right, you got it. So,
good enough, she means, right?
I don't know.
What do you care? I did the same thing. That's why I just went with the even thing. If I can't see it, I can't do any fancy styling. It's all going to be the same length. I can handle that.
Spock had it going on, the bowl cut. J-Rock 69 says, comment reply to me. It's because the ether is solid. Dude, I hope he's drunk.
Do we think the ether is real? Are we agreeing on the ether?
Well, he
or
didn't write ether. He wrote either, E-I-T-H-E-R.
Right.
I don't know if he's meaning, and I always spell ether as A-E-T-H-E-R. Yeah, and I usually say aether just to make it clear that it's not talking about the stuff you spray in your engine to make it start when it's not feeling good. Kuros says the field of geology has many instances where even decades can go by of peer review disagreeing with a particular hypothesis and conclusion until more and more evidence comes along supporting it before it becomes acknowledged.
And in that example, the first reach conclusion has a much stronger position than anything that comes after it to try and replace it. No,
it
that's
does.
why it takes so long.
It does, but it's not always the case. Do you know Vera Rubin?
No. Right.
Do you know Vera Rubin?
No, I don't know who that is.
All right. So Vera Rubin, number one, was a female in astronomy back when there were not a lot of females in astronomy. So she had an uphill battle there. She and I forgot the name of the guy. He's a little brusque, a little prickly, like Cracker. Identified that galaxies were rotating too quickly based on how much mass they thought was in the galaxies. And Vera was the second one to kind of come into this, but she published some stuff and it was not accepted. People were not ready for it. But in the end, she kept going, and eventually her position was accepted because she just had the backing for it. And that's where we get dark matter from, is the they call it the galaxy rotation problem. That they
The
rotate
missing
faster
variable that
than
makes
is
gravity
predicted.
work, right? It's there to explain the forces of gravity that we've already presupposed.
Well, measured. All of this is measured. There's no presupposition. So yes, it's, if it didn't become the accepted position on accident, typically, sometimes it did, but there's a lot of reasons for it. And so, yeah, unseating something takes some challenge, but it's available to be done. So
I see. That's the argument there. I mean, I didn't know that there was, I'm sure there was examples on that model. I just found a problem with the model. If I was on the other side, I'd have a hell of an uphill battle to get my new contradictory idea published, right? And if they don't like me, boy, they're going to pay money, have me done, take my stuff, attack my study, refute my result, all that stuff. I'm sure happens as well.
all right, Jay Dud says Shane just needs a cuddle and a
I
bowl of
did look like,
spaghetti, and he'll be fine.
I'm fine now, man. I got no hostility, and I appreciate getting made fun of by your chat. I got thick skin, dude. I've heard them all. I ain't afraid.
Oh, here's a good one. LB Things, Stuff, and More says, Shane, here's a challenge. Study the globe for 30 days. Yes or
I
no?
studied it for 18 years, friends. Right, we all did. Well,
But I've pointed out a few things.
no one studied it like you have, though. The rest of us get told it, and we don't question a thing, and we just accept what we've been told with no verification. And then we go, wait, you've done your own verification to prove it to your own satisfaction. That's very rare, I think, in the people who believe the Earth is right. If you ask that person on the street how fast is the Earth spinning, no one's going to know that. Most people don't know that offhand.
It to most people, it doesn't matter.
Right. They've never thought about it. And I was,
it's a top there. And Shane, there's billions of topics that people don't that doesn't affect people, that they don't need to worry about, that they're not experts in.
Right.
This is just one of many topics that people don't have depth in.
Or things that we accept on principle or face value without doing any research
and nobody
whatsoever.
can build the expertise necessary to individually test everything.
Right. And most people don't care. That's the general rule I'm finding, right? That's why that's how we got to the thing that happened a year and a half ago.
So, all right. Zoomy says, has anyone ever decided to, as far as do look more? Zoomy, where did you English this out? Has anyone ever decided to, as far as do look more?
I understand perfectly. My answer is F.
Zoomy has been on here. I know Zoomy.
Is there a question there that you can piece together?
I don't know. I hope Zoomy's had been imbibing tonight. Has anyone ever decided to? Zoomy, what the crap?
People decide to be stupid, endure endless hours of ridicule, and take the counter position just for fun.
Here's from David Brock, who is a surveying instructor at university. This is the text that the class uses. Says, unseating a consensus hypothesis takes work, and really engaging with the consensus hypothesis to point out how your hypothesis better explains a given phenomenon.
100%. But if I owned all the people and I owned all the researchers and I gave the grant money, it's a hell of a disadvantage, is all I'm saying. Right? Science finds that the studies conclude who pays them more, right? The conclusion that they're given with the most money.
I think that's more on the other end of the spectrum of hard sciences, right? Physics is more on the pure side. You get towards chemistry, it's a little, and biology, come on. They're all, I'm kidding. But,
We can't define a woman, so I don't want to go there.
Don't go there. Go. So Professor Dave Explains had a very good video on that particular topic. And I
A woman? That one I might actually watch from him.
I appreciate his position, and he called out everybody and had and himself had a position that maybe is less popular.
Only two sexes, you mean? Or
I-
something beyond
I-
that?
He made a distinction between gender and sex. And he
Right.
also had a position on sports. And he's not a guy that's into sports, but he had a position on sports that might not be that popular. And I commend him for doing that. So, and I cannot find fault with what he said. So, people,
Wow.
if you've watched it, you now have a good insight into my position. So Jiffy Cones says for $3.33, MC Toon said cockpit.
That's better than the $3 we had, I guess.
What about Lake Titicaca?
What about it?
It's my favorite lake.
I love saying the name.
Just because of the name. Heat Shield says NASA bonus for the book for by the book haircut.
Is that
There
me
you
or
go.
you?
All right.
That's you by the book
That's-
NASA haircut?
I think that's me. Yeah, NASA pays me the big bonuses because I do the haircut the way they say.
I get the cheap buzz that they probably give the astronauts, though,
Um,
right?
Yeah, or Heat Shield. Make sure tell Betty, not Karen, because Karen will never process that bonus. Karen, HR, she's a pain. Liquid Flame says the Channel 74 gear run by a 747 pilot has a Kickstarter to fly Buenos Aires to Perth.
I heard
Which,
about him.
with flat Earth claims, is impossible. Do that instead of a rocket. Unfortunately, that Kickstarter expired. There was a certain time frame, and he had to then do it or
And they
don't
were
do it.
willing and able. And I guess
And-
there was a change of plan or something that didn't happen or whatever.
Well, there wasn't enough interest, so it did not get funded. So nobody was charged, including myself. I
Did you?
pledged.
You ran on that? Oh, wow.
Yeah.
Did they return the money at the end then?
Yeah, they never actually charge you. That's week.
Oh,
That particular one. I would have wanted to go, and there was a flat earther that was saying he might be interested in making sure that I got to go.
right. I think we can get along on something like that. If we just fly over Antarctica, it'll prove us all stupid shot, right?
So Zoomy says, Zoomy who had that excellent English earlier, says I has goodly English, brain melty, blame flurf. So that's on you, apparently.
Dude, that's the best follow-up that I ever could have predicted.
We've got
Dude,
Geist
hats off to that guy.
says, in regards to my comment, south equals down, ask him to point to south and down at the same time. So point south.
What?
Point south.
South is every direction away from the center.
I'm pointing from where I am right now. I'm pointing south. Can you point south?
South is that way.
All right,
North.
and I'm pointing down. This is down. So right on the globe, they're not the same direction,
No.
right? But
South.
you see, if you memes have show like water falling off the bottom of the globe.
No
Like,
one
that's
believed
not-
that, though. That's nonsense.
Some flat earthers post that constantly, like they think that's really the case.
There's a lot of people putting dumb shit out on purpose, just like there was for the other issue that we don't talk about on YouTube, right? That kind of has the same strategy, and this one's been going on longer. But the directions make perfect sense on a flat Earth. Actually, that's one of those things that work perfectly on both models. So it's a silly argument to pick, I think.
There are some things where it's the same, and
Right.
misunderstanding it doesn't.
Right. I think most
All right.
things work on both.
This is a very eloquent one here from Jeffrey Hollenbeck. Says, Mick Toon, did you ever have their act to do another again after the no over not and think do a pontificate while doing? Right, we maybe missed that. I'll read it again. Mick Toon, did you ever have their act to do a with another again after the no, or no, over, not, and think do a pontificate while doing?
Seven backwards gravity unicorn. That's the answer. That's the best.
That's a great question. I'll have to get back to you on that. Ron Tronimus says, giving conspiracy theorists a bad name with that shirt. If you care to
Yeah, I
actually
get it.
learn anything, check out Rule by Secrecy by Jim Mars. Never heard of
Who's that? Repeat it one more time.
Rule by Secrecy by Jim Mars.
Thank you, sir. I will look into that one.
And it's probably my favorite Homer Simpson quote by Pat in the chat. Me fail English? That's impossible.
Oh, not dope. Rule by secrecy, the hidden connects trilateral Freemasons and Greek. I'd 100% agree with that one, man. That's interesting. But thanks, man.
I don't know why I just promoted that, Ron Tron. What the heck?
Don't take my shirt personally.
I have, is it, I think it's up here. I moved it. It's On a Pale Horse I have.
Yep, that's the one I would counter reference if no one's read it, heard of it. A good one, right?
And no,
Can we say that on here?
It's all nonsense. It
Really?
is so derpy.
Well, I think Bill Cooper's a little nonsense. I think what he was saying kind of is corroborated elsewhere.
Bill Cooper and Sanity have yet to meet. Danny says, who's been a member for 3 months. You broke my heart with South. ND down. South not being down.
Yeah.
Danny.
That's one of them free support. That's like a cracker question. We have to answer the way I want you to so I can do my response and rebuttal the way I planned it. All right.
Well, here's a question from Abelus. Please explain why only Mercury and Venus transit the sun and no other planets do.
We also don't know what the fake space station is. We don't know what that is.
Dude, don't change the topic. Don't deflect.
I don't know. I don't know why that is. That's something that I don't have an explanation for, man.
All right. Well, good. The globe predicts it. VSOP 87 will tell you when it's going to happen.
Yep. I got you on that one. Touche.
So, all right. Well, oh my goodness, we're coming up on
Good stuff,
4
man.
hours.
Was it? Holy shit, huh?
Well,
however you found me, man, I'm glad you did. I appreciate coming on. I had a good chat. Sorry for some of my friends.
hey, Cracker's prickly. We've got to soak him in water beforehand so he's a little squishy.
He's never that emotional when I'm talking. We had a good 4-hour chat today, and all of a sudden you got angry. I'm like, dude, we looked at it, we watched them together, we joked about it, we got here. What happened? You know he's gonna rile you up. You know he's gonna poke at you. Relax. It's okay.
He started going down towards DMOC zone, and if you want to watch somebody go crazy, watch the most recent debate. It's not a debate.
I watched snippets of it.
DMOC. Oh my goodness.
But I knew there was no chance of me convincing you of nothing or you convincing me. It was a good debate to show the supporters, right? I mean,
it's a debate. This is on your channel too, right?
Right. But I mean, I didn't come here to convince you to change your mind. I didn't think that was a goal, right? That's silly. That was guaranteed to fail.
Do you disagree with Cracker on some of these points?
I disagree with his approach, explanation, and rationalization. I think the principles we agree on, but I don't think we worded them correctly, and I think emotions took a toll.
What about his position that on the rotating oblate spheroid, that if you throw a ball up, that it must start flying laterally?
I think that there's some arguments that didn't do anything to me. Like when I was looking at the curvature math of flat Earth, they were like, "Look, no curve, it's flat." Drop. I was like, that doesn't show me anything. I don't get anything from that. And the motion on a plane where if it stops, you should feel it going. Or we have specular reflections on a lake, but that's why the Earth is flat. I'm like, that doesn't really prove anything to me. Those are just arguments to maybe they blew someone else's mind. I rolled right past those like they were nothing, right? So I don't know. It's different for everyone, the things that trigger your specific curiosity, right? And start questioning things.
People are responding to DMOC. Let's see. Is J-Rock was a little incoherent. Let's see.
Oh, drinking, that makes sense.
Says you degen's gonna make me cry.
Who's degen? Me?
Oh no.
Oh.
I think J-Rock is just happy that Zoomy came in with a more nonsensical super chat than he did. All right. J-Rock says, MC Tune, Titicaca, sorry for not being able to spell on my cell phone sometimes.
What was did he bring up Titicaca? Was that, I thought you just whipped that out of the air. That was a question involving Titicaca?
Lake Titicaca is a recurring theme here. As is lots of open tabs. And I'm all out of Toonshine almost. But to drink
is that what you've been drinking? Yeah. Nuts.
It's just as much proof as Eric DeBay's 200 proofs.
More proof than gravity.
All right. Well, we've got Pat in the chat says, thanks for the good conversation, Shane. Cheers.
Appreciate it, guys. Appreciate dished out the worst we could take. Dude, most of us love to be challenged. I love to argue the counterpoint just for the fun of it sometimes, right? It's been boring if you all agree.
Well, all right. I appreciate it, Shane. It's been good.
If I can get Weiss to agree, I'm gonna send you an email, man, just for funs and giggles. I would love to see that.
Absolutely.
You
Though
can both page.
when he was on, I have a clip of him on Jaren where him and Jaren are talking about debating anybody except for me and FTFE. They won't debate us.
Well, I could see. I mean, he's not going to gain nothing by coming. It'd be just an entertainment thing, I think, right? For his fans and your fans. I think he's going to try and sway some of your fans. You try and sway some of his. That's the interaction, I think, right?
Shane, you know what I'm doing here? This is entertainment for intelligent people.
Right.
Yeah. Professor Phil Bell says, please ask him if he would take a serious look at the evidence for both flat and globe.
Absolutely. That's why I'm on this show, man, right? No? Isn't that a good example? Why would I come on here if I didn't want to do that?
Yeah. Jeez. Yeah, and another good place to go would be Djibouti. I do like.
Are you making
Djibouti.
up words again?
No, that's a place. It's Djibouti. You don't know where Djibouti is?
No, should I? What the hell?
It's in northern Africa.
Oh yeah, that Djibouti. I couldn't spell it or point to it on a map. Oh, there it is.
It starts with not a J. It starts with a D.
It's near a whole bunch of other words I can't pronounce. Perfect. I know exactly where it is.
Pat in the chat. Isn't Dearth still in the burn unit?
Everyone hates Dearth, huh?
After the Professor Dave.
That was a bad one, dude. I loved Dearth. I watched that and I went, ooh, minus 10 points, dude. I don't know what happened there. Is it because they couldn't let you show stuff or what? What happened?
I mean,
there?
the moderation took a dump.
Is that, I mean, was he disadvantaged or drunk or what? What happened there, dude? Why? I don't know.
Professor Dave was just on fire. It was.
Well, he was pre-prepared, right? And he overtalked and interrupted and didn't let Dave talk either. That was the other thing I didn't like from both sides.
Dearth is used to going on to talk shows where he sets it up and the other people that he's talking to don't know the topic.
Right.
And he's used to being able to make a claim and not actually be challenged on it.
He wasn't ever. That's probably fair. He also only goes on people who think the Earth is a globe but have done no research and know nothing about flat Earth. That's his target audience, and he does really well there. Exactly. He even come on my show. I don't want to talk to flat Earthers. I'm like, well, don't. You know, you don't have to.
He did come on your show?
One of my first shows ever. That's how I started doing live shows. I wanted to talk to Dave.
You have like 27 channels.
On YouTube. YouTube's not my place to go. I get banned there constantly. BitChute, Odyssey, and Rumble's where I live. Right, that's where my 6,000, 8 people that I built up. YouTube is not like me.
How many?
About 6,000 on BitChute, 4,000 on Odyssey.
How many? How many are watching right now? Hello, everybody.
Actually, I closed it like 10 minutes ago. I closed on my side of it, but it was I think like 40 on Rumble and 200 on Odyssey. Which I didn't read any of the comments. Sorry, dudes. You should know that. I never do. I always forget. Whoops.
All right, I got a couple more. Jürgen Lundqvist.
German. I got a German friend.
It could be some other Slavic. It's got umlauts over the so Jürgen Lundqvist. Oh no. He's not German, he's Norwegian. He or she. It sounds, I think Jürgen. Anyway. For 100 Nokias. That's how I know it's a Norwegian kroner. Says MC Tune rules. Take that.
Your t-shirt is cool. I like the logo. Right?
I made this. That's
I believe you.
And this right here, that is myself there, right here, and Schrodinger's cat, who is no longer with us.
Is that a real cat you had? It wasn't a science experiment callback for a globe cat.
No, it's a person. Schrodinger's cat.
Right.
His name's Cliff. He had a channel. He started out doing the same topic, moved on to sovereign citizens and First Amendment auditors, and had a very successful channel. And then in late January, passed away unexpectedly while in a hotel. So
sorry to hear that.
Traveling for work. And that night he was on. This is a channel, the SC Toon Show, that he and I started together. So
Oh man, that
we
sucks.
we had done a show, and still sad. Still think about him every day. Anyway, Danny says, I want to say, Micktoon, we love you and thank you for all the wonderful laughs and all these flirfs. And then a bunch of emojis. A smiling heart eyes emoji and a heart, and then more hearts and a heart, and then a heart with an arrow through it. So
No sausages or eggplants, right?
yep, no, none of them.
I'm good then.
Eggplant peach. Then Ableist for 5 Canadians says, thank you, gentlemen, for such a respectful debate. Honestly, it's refreshing. Thank you for that. Anything as we wrap up that you'd like to add?
No, but maybe we can do another one in a couple of months if you got a free schedule. Do another chat, bring some other friends on maybe, and do a little repeat. Try to prove Earth is flat to you the next time.
All right. Maybe focus in. You know what? I like narrow focus.
Yeah.
And I don't like memes. It's the opposite of a meme. So if you can get
I got you.
detail
I'm with
on
you.
something, I think that'd be awesome.
Scholarly debates, and if we focus on specific topic, we can prepare and bring it to you, and then make you walk into our prepared responses so we can laugh at you. I'm just kidding. Honestly, I was genuinely interested to see your answers to these, and you didn't disappoint, right? They made sense to me. Couldn't refute it, as you say.
I'd like to tell us what force moves the water in a water level. All right. It's not
Electromagnetic moon.
Oh my goodness.
I still got it in. If you don't refute it, I win.
That's the opposite of how it works. I have, for those that don't know, if you're 4 hours into watching this after the fact, then you certainly are a trooper. I have another channel. It was given to me by Conspiracy Cats. It is currently called Conspiracy Cats Toon. It will eventually just be MC Toon. That is the channel I'm doing pre-recorded videos on. This channel will continue to be live ones. If you're not subscribed to that, the link is in the description. The link to all of Shane's stuff is a link tree in the description.
I welcome shit comments on everything I post. Come tell me how dumb I am. I love it. Or at least make an argument. We'll get back and forth.
Well, there you go. So, anyway, thank you, everybody. Shane, you don't have to end the call here. As I close this, we can talk afterward. But anyway, everybody, thanks a lot. We'll see you next Tuesday.
Good luck, everyone. Thank you, guys. Appreciate it. Have a good night, everyone.